Am I audible?
Yes, you are. Am I audible?
Yes, you are audible. Am I visible?
Yes, you are. Am I visible?
Yes, you are visible, but am I audible?
Yes, I can hear you. Am I audible and am I visible?
Yes, you are audible and visible. I think we should just get started.
Hello and welcome to the day 2 of UINXT 2021.
This is Mayank, an ardent web UI developer here at Globant and believes that procrastination is a sin. Just believes.
And this is Harsha, another web UI developer at Globant. She's crazy and borderline maniac about pizza.
And we are your hosts for this evening.
So I'm sure you must have truly enjoyed our day 1, learned a lot and exercised your brain to the fullest with some mind-boggling ideas discussed.
We are bringing you another evening full of new and innovative ideas. Because innovation, we can do it all day.
So we have organized exciting goodies for the best tweets. How we'll know your tweet? Just tag us in UINXT. And we encourage you to stay with us till the end of the session so that we could have live Q&A sessions with all the virtual booths discussed.
Moving on, knowledge has a beginning but no end. So let's continue getting more knowledge and listening to more thought-provoking ideas. But before we start with our first talk, let's see what the virtual booths hold for us today.
That was awesome. The future of shopping lies here. Wouldn't it be amazing to shop this way, Harsha?
Well, I'll be looking forward to shopping like that. Stay tuned for more such a teasers as we will be showcasing more such a ideas in our virtual booths. As yesterday, we have the virtual booths open from 7 to 8 p.m. today. And keep tweeting hashtag UINX to win amazing goodies from our side.
So now moving on to the talks. We are opening our day today with Web Next Stories. We have a senior search and web ecosystem consultant at Google and an international tech speaker. He's also working towards modernizing the web at Google Search. Please welcome with me Saurabh Rajpal to the third edition of UINXT. Saurabh, the stage is all yours.
Hello G, Namaste Adab Sat Sri Akal. A very warm welcome to one and all. Thanks to the host for such a lovely introduction, and thanks to the developer audience of UNXT for tuning in today right on time. My name is Saurabh and I am a web and search ecosystem consultant at Google. I love to connect with people and can be found on Twitter, LinkedIn and Instagram with my handle I am Saurabh Rajpal. Now let's get started with the amazing topic for today. There are two reasons why I chose my topic as Web Next Stories. One, because we're going to talk about web stories. And two, because it's the next gen format for modern web. And well, next gen is what we witness at UINXT, don't we? So without further ado, let's get going. Let's have a quick look of what's in store for you today. Chances are you're like everyone else and really enjoy the story format. It's visually rich and easy to consume. It is one of the fastest growing ways to consume media. Till now, the open web was missing out on the beloved format. But with the introduction of web stories, not anymore. So in this talk, you'll learn what are web stories and where you can find them. Then We'll deep dive on how to make amazing web stories from the word go. We'll keep in mind the best practices across the content, design, and SEO. Then we'll go through some of the interactive components available today, which can help you engage with your audience much better. And in the end, we'll quickly build a live web story for UINXT event agenda in less than 5 minutes. Yes, you heard that right. In less than 5 minutes. Cool. So let's get to our first section. What are web stories and where you can find them on Google? I'll quickly walk the audience through the story format in general before I move on to the web stories specifically. So for the starters, stories are always full screen, portrait, and immersive. And of course, stories allow you to swipe to go to the next story if there is one, and so on. Web stories keep this consistent experience you have come to love, but offers some great benefits to you both as a creator and reader. So why has this style of producing content become so popular? Let's see what the stats tell us. Tappable stories have become a major part of the way consumers engage with content today. In fact, 60% of weekly mobile content users now consume tappable stories daily on social media. In a recent Forrester study, they found 84% of users felt tappable stories met or exceeded the expectation for the ease of navigation. Consumers were also 1.4 times more likely to find the method of navigating the tappable more appealing compared to its scrolling equivalent. As the Forrester study suggests, there is a unique opportunity for everyone to reach their audiences with a familiar tappable story format. And that's exactly where the web stories bring that format to the open web and allow anyone to take control of their content without being confined to a single ecosystem. So now that we understand the common characteristics of a story format, let's take a closer look at web stories. Web stories are web-based version of the popular stories format that blend the video, audio, images, animation, and text to create a dynamic consumption experience. But why should you create web stories? Let's look at the 4 key reasons. First, it gives you the creative control. Web stories are entirely under your discretion, just like any other content on your website. Each story can be designed to fit your brand. Second, it's monetizable. Web story authors retain 100% of any monetization with ads or affiliate links and are in full control of hosting, sharing, linking, like whatever you want to do with those stories. Number 3, it's connected. Not only are stories easy to share and embed, you can also link to your other content. We have already seen many users linking to stories from their home pages, social media channels, and even newsletters. And lastly, they don't expire. The stories live on your website as long as you would want to. So web stories can be created by anyone, as I've mentioned before, whether you are an individual creator or a publisher. In fact, more than 2000 websites have already published stories that are now available at Google. You can see some sample stories at google.stories/showcase. And if you'd like to hear more of such stats around how this web story format has been killing it, just go and have a look at this episode on Google Web Creators YouTube channel. This channel shares some amazing bit-sized content around web stories, and hence, I think you should not forget to hit the subscribe button. So now that we understand what web stories are, let's talk about where you can see them. Stories are web pages and can be seen anywhere a web page can be seen, but Google is going the extra mile to let them shine. So as we know, organic is everywhere. Whatever you have seen so far of Google search, it's already there. Blue links, top stories, image search, discover organic cards. You talk about it and it's there. There are multiple other dedicated avenues which are work in progress, and you may start seeing them soon on Google search as well. One can also find these in the Google Discover carousel, which is currently available only in US, Brazil, and India. So for the ones who are looking baffled about what exactly Discover is, there are many ways you can access it on the apps and on the web. Let me share some of the most common ways for you to do that. So for Android users, if you have an Android Pixel phone, for example, You could swipe right on the home screen and you will land on the -1 screen, which is Google Discover. Or you could download a Google app and you'll see your Discover feed. Same goes for iOS users as well. Similarly, how you could do it on Android, you could download the Google app and the Discover has a dedicated tab there. Irrespective of Android or iOS or any other OS, when you visit google.com from any browser on your mobile device, you'll start to notice a feed, and that is Discover. And finally, if you have or if you use Chrome on your mobile, whenever you open a new tab, you'll see a Discover feed just below your recently visited sites. So best part is there is a dedicated web story player built to run these stories, and hence it offers a frictionless experience. With just a tap or a swipe, it's easy for readers to consume as many stories as they want. And you know what? The good news is that even if you can build your own story player on your website and integrate web stories into your site experience. Speaking of building your owned and operated experience, there are many more avenues where you can embed or link to web stories. For example, user profile images could be linked to open as stories. There could be carousel of stories that you want your users to view categorically, and so much more. So here is a very quick view or the demonstration of what I was talking about. A singleton is a single standalone story. Carousel clubs the set of stories in a vertically browsable format, plus you could do it categorically as well. There is an author highlight, which you could use for boosting the profile story visits. And you could even have a full dedicated page where you can mix match all of these options, which will provide an amazing go-to place for all your web stories, and user will be able to browse things like these seamlessly. Oh, so finally, end of introduction. I know you techie folks are dying to jump into the actual action. Hopefully, at this point, you are either interested in consuming or making your own stories. So time to get your story out there. Building a web story can be broken into 5 simple steps. 1. Tool prep. 2. Drafting the story. 3. Sourcing the content. 4. Creating the story. And 5th, of course, publishing the story. You certainly don't want to restrict your amazing web stories just to yourself, right? So let's look at this step number 1, which is the prep. For this, you have to select a story creation tool. Now, drag and drop tools like the web story editor for WordPress, Make Stories, and Newsroom AI make it easy to create web stories in minutes to your website. These editors require no coding skills, and pages can be dragged together and configured similar to a design tool. If you are interested in learning more about these tools, go to these links which are listed right next to them, or you could visit stories.google, where you will find many more editor tools like these. Now, each of these drag and drop tools which we saw earlier would have their own features and UI design. And for the most part, they'd have most commonly used features which caters to most of the web story creator audience. However, as a techie developer, you can go the extra mile and actually code these stories by yourself. These are based on the AMP framework, and you can build a visually rich web story with just a few lines of code. This way, the developers have full flexibility of the way they want to build their stories. I brought up this point specifically here because the major audience expected at this UINXT conference is developer audience. However, I'd still recommend you to use one of the previously mentioned tools to get a feel of how stories could look and how could they work. And in fact, just in case most of your requirements can already be met by one of them. Lastly, there is also no harm in saving some development time by building stories on these tools and modifying the code of your stories as per your choice for the needed missing use case. Let's talk about step number 2, which is drafting your storyline. Before sitting down and creating your story, you need to do your homework to find a concept, to write a compelling story arc, and to source the creative assets. Some of these sample tasks include shooting or sourcing required video and imagery. 2. Crop and optimize media to fit the vertical orientation of mobile web stories. You could also figure out monetization opportunities, do some more research on topic you want to cover, and so on. One thing that might not be super obvious at first is that a web story isn't a single page at a time, like on most social media platforms. Like as you would see and you must be used to, you just can add anything to the story in the social media platform and they can all coexist. But in a in the web story world, each web story is a self-contained editorial story with a beginning and end. So this story will naturally have multiple pages. I personally like to write an outline first and really focus on creating a great story arc. This isn't for everyone. Like maybe you want to skip this step and dive right in, but it really works for me, and I think it will work for you too. I like to use Google Docs for this, but totally up to you. So step number 3, which is sourcing. Now this I think is the hardest part because you need to source the right content. The right imagery or videos are the make or break of a good web story. If you have been blogging on the web, you would think of this as a counterintuitive, right? You would find this counterintuitive. Because with a typical blog post or article, you start with a copy and then find some images to visualize the point. With a web story, you start with the image and then write some copy to clarify your point because this is a visually rich format, unlike your blogs or any other content or website. Number 4, make it your own. Take the time to customize your story and make it feel like your personal brand. Later in this talk, we will discuss some web story creation best practices. But for now, here are 3 important tips to make your story more engaging. First, ensure that all of your text in the story is visible to the reader. The burned in text should be avoided to prevent text from overflowing when resized to fit various device sizes. Second, bring your stories to life with animations, but avoid distracting or repetitive animations which can cause fatigue. Third, first person story works great. Share your opinions. Be the protagonist of your own story. Make it relatable to your audience. And last step, optimize it. Learn from the engagement stats so your next story reaches an even greater audience. Google Search Console now provides additional details about how your web stories are performing in search and discover. Cool. So let's learn some more web story design tips and best practices. This is an even more important section for developers because unlike the content creators and bloggers, we as techies forget to put some thoughts into it at the first place. So please do take a note of it. So first, your cover page is your web story's packaging. It's the first thing which viewers will see, and if they don't open it, the only thing they will see. Make sure it's appealing. A good cover page has 2 elements, eye-catching imagery and a short, memorable title. The titles should not be longer than 90 characters. In fact, we recommend having a descriptive title that are shorter than 70 characters. We also recommend that you use your own logo rather than the default logo which is provided by a creation tool or some image that you find on Google search. Tell a compelling story and be concise. Try to reduce the text to approximately 280 characters per page, which is fairly the length of a tweet as well. Double check to make sure that your story does not have any text that flows off the page. Ensure that all the text in your story is visible to the reader. Accessibility matters. Broadly speaking, when we say a site is accessible, we mean that the site's content is available and its functionality can be operated literally by anyone. So when it comes to stories, avoid having a story that contains text that blends into the background, which could be an image or a video, and it could make the pages difficult to read. So just avoid that. Also, please be sure to provide contrast between the text and the background images so that, again, the legibility part, so that it's readable. Now, resize videos to make room for text and captions at the bottom. Not all readers will be able or want to hear video content. Captions help keep your audience engaged even when they can't listen to the audio. Just imagine you are in a public place and you're consuming this story. If you don't have a microphone with you or a headphone with you, you would have to unmute and be in a uncomfortable space. So now that's what I'm trying to make a point here. Without captions, your audience needs to be able to listen to audio to follow your story. This may limit who engages with your content and when they are able to do so. Use a mix of high quality assets. Video is more engaging than text or images. Use as much video as possible and append with images and text in between. Bring your stories to life with animations, but avoid distracting or repetitive animations which can cause fatigue. Now, timing and style add to the tone and message of a story. So choose an animation style that suits your aesthetic, and then be mindful of how quickly the things move. Like moving from one page of the story to another, you could have automated it. If you would actually automatically advance to a next page very quickly, that could mean that your users are not able to read the full text. So you should consider slowing down the auto advance so that there's ample time for the readers before they go to the next page. So web stories have a built-in mechanism to attach metadata to a story. This ensures that maximum compatibility with the search engines which are out there and the discovery features which are available there, it can be taken advantage of. Don't worry if you're using a like existing creation tool, most of them take care of this. But if you're building something out of your own, ensure that you do your research and add the metadata to your web stories. And in fact, speaking of SEO, so there are many more story specific SEO guidelines and tips which are covered in this 3.5 minute like amazing episode on Google Web Creators YouTube channel. So let's look at the last section before we move on to the live demo part. Remember, I promised to make a live story in under 5 minutes. Web stories are getting even better with a new set of highly interactive features. To best demonstrate how the new features can elevate both the narrative and storytelling, the web story team collaborated with an amazing 3D artist, Sean, to create this spatial web story, Home Warrior. This was to celebrate how people fought this pandemic from home, and meanwhile, also test out the new format features. If you have your phone with you, get the Home Warrior story on your phone by either scanning the QR code or type in this URL. You will be experiencing the main character's one-day life at home by completing a series of missions. So let's talk about the first feature. The first is the 360 media support. The 360-degree media, consisting of 360-degree videos and images, is a great way to enhance your storytelling with a more immersive experience. As the example you see on the screen, in the Home Warrior story, we embed a full-screen 360-degree image of the internal apartment, which could provide the viewers with much more fun and engaging experience in looking for the cat in space. The 360 media on the page are explorable via the device's gyroscope sensor. You can also choose to animate the 360 media between 2 points. Please check out the documentation link on the screen for more implementation details. These are exciting opportunities to add this immersive experience to your stories, like if you would want to do a fashion, travel, or gaming story, for example. I really can't wait to see the creativity that you bring in by leveraging the new 360-degree media support in this. Up next is the new interactive component. The interactive component provides a set of engaging interactive experiences, such as polls or quizzes in a web story. Using the interactive components at the right moment of your storytelling will be a great way to boost viewers' engagement and create a connection between you and your viewers. On the current screen, you can see the example using a binary poll on the page for picking the outfits of the day from the Home Warrior story. Using the poll component often offers viewers a direct view to give feedback and lets you as a creator understand your community better. It will also increase engagement as users will compare the selections with everyone else. It will display the voting percentages right after the viewer makes a vote, along with the emoji confetti effect if you specify. You can receive the results directly from your server or use the backend provided by the story creation tools. Please check out the documentation link on the screen for the implementation details. Though often lumped together with polls, quizzes in web stories serve a very different purpose from a storytelling usage perspective. So polls tend to gather more open feedback, while quizzes provide a guessing experience with 2 to 4 options, and one of which would be correct. As the example you see on the screen, the quiz asks what will be a good indoor temperature to help save energy during summer. After the viewer makes a selection, it displays the voting percentages and the choice will be highlighted in green if it is correct or red if it is incorrect. You can also add an emoji confetti effect to celebrate the viewer's victory. Now let's talk about the design flexibilities to add interactive components to your page design. At a high level, an interactive component comes with 2 parts as default. A prompt section for a quiz for a question with the format provided typography style, and options section to let you add 2 to 4 options responding to the question. You can choose to use both units or just using the option section, and add your question separately with your typography treatment. For the poll component, we also offer a unique design layout called the binary poll, which takes the page's minimal design space, like the first two examples you see on the screen. The format provides three main UI themes: light, dark, and transparent. You can pick a theme based on how the main visual style would look on your page. In fact, in addition to that, you can also choose an option like chip between flat style or shadow style. You can access the supportive CSS variables and attributes and override default variables by assigning a class to the elements to make the component visually style best fit into your page design. Another excellent way to use your web story interactive components is to design the entire storyline using polls or quizzes on multiple pages. Like the animals polls example here on the screen, you can lay out an engaging story by setting up different questions on various pages. The backend will aggregate results from polls on all the pages and lead the viewers to the relevant result page based on their selections. You, as a creator, can craft customized results page based on the viewer's choice and offer unique experiences with each of your audience. Feel free to get this demo story on your phone by either scanning the QR code or type in the URL which is mentioned there. Hope your spirit animal is matching your expectations. Similarly, you can also create a great story by using quizzes on multiple pages. As the same logic as the polls on multiple pages, the backend will aggregate results from the quizzes on different pages and generate a results page for the viewers in the end. Because the quizzes calculate the correct and incorrect results from each component, you can set the final results page to show different levels based on viewers' accuracy, like the art quiz story demo which is presented on your screen. Now that we have done with what web stories are, where you can find them, what are the best practices, let's quickly go to and check out a demo. For this demo purpose, I'll be using a web stories plugin which I have pre-installed. So just give me a second. Let me stop sharing and then share the screen again. Okay, where is, yes, here it is. Cool. So as you would see, I have the stories plugin already installed on my WordPress instance. So just in case you're already using a paid version of WordPress, or you're hosting your own WordPress version, you could download this plugin too, and you could start creating stories. This is the dashboard which shows all the stories that you've created so far. For me, I just did a test story right now, right before this, so that I could do the live demo, and that's why I'm just showing one story right now. Now, a bit more about this page here. So you could like start a new story with a blank state, and you could just add on pages and do stuff, or you could explore the templates which are already available. And as a first time creator, I feel if you could come here and explore templates which could help you build, that will be like super impressive and useful for you. So as you would see, there are tons of like templates which are already provided. And in fact, I think the team plans to add even more of such things. You could choose, you could read more about a particular template, like what are the kind of pages which are available in this, if it really would fit in your choice or the intent that you have. So for this current demo, I intend to create a, say, a promotional web story for UINXT event, right? So maybe this layout gives me a sense that I could do that. So what I do is I'll just click on use template, and I'll wait for a while before this like initiates and gives me the canvas where I can do all the things. Now this is your canvas area, and these are all the stories that you have in this particular template. I could move things around, I could change the elements, and I will be able to make a story. I'll be showing you some more features of this web story plugin right when I'm doing the customizations. So to begin with, I think as a audience, what is that one thing which the audience would love to see on the first page? Of course, they would want to see a Globant logo. That is the brand identity, because UINXT is Globant's event, right? Now, thinking of what could be the cover image. So this is the media that I had already uploaded, and in fact, you could upload more media as per your choice based on the assets that you have. Otherwise, you could also go to the third party media and So for example, I would want to use a conference photo here. I'll search for conference and then browse through all the images which are available. Let's see which, maybe this one works out the best. So I'll just drag and drop this here. So this goes as my background image. Now, as a title, what would I want to share? Maybe say welcome to UINXT, right? And if you want to see how this would look, there is a preview button for this particular page right at the bottom right. If you do play, this is how exactly this would look like. When you're starting afresh, you would have to add all these animations and stuff like that by yourself. And it's very easy because it's very intuitive from the right hand side options that you have. But because we were using this template, it automatically appended or added these animations onto the components. Now, this is done as a welcome screen. What would you want to give as a next slide? You probably could want to give the 3 reasons why you should attend, right? So why should you attend? You could, or if you want to just do it, you could say why to attend, which is just taking this much space. Now, from the website, if I have to check, they mentioned insights on future of UI engineering, right? So let's type that. Insights of UI engineering, right? The other one could be experience the cutting edge tech, and third could be network with like-minded people, right? You could also like just change the images. So for me, probably I'll choose this one for insights on UI engineering. For cutting edge, I could again do a search here if I don't want to upload. Let's see what I get. Cutting edge, what represents cutting edge? Maybe this. Let's try this. Okay. Yes. And network with the like-minded people. This looks like okay. So let's skip ahead. Now, what else I could do? So I could say this is how this is this is events. I could do agenda. I could increase the size. The reason I'm adding a agenda as a separate one is so that I could leverage the separate what do you say, the animation that is already there. I could expand this just so that it accommodates. I could do this, and let's see how this looks like. This is events agenda, and for the agenda I could use something like this. For example, wearing, I could just add the day one. I could replicate or duplicate this page and then add day two. I'll again duplicate this page and I'll add day three. Oh, sorry. I'll have to choose at the top left corner. So basically now we have a slide which welcomes the UINXT. There is a why to attend page. This is events agenda. We have 3 pages of agenda, and then maybe I could introduce the speaker, right, in this way. So we could write Saurabh Rajpal, Google, sorry, and we could say listen about web stories, as minimal as possible, and then we could expand on to like add more things, or we could just delete it to have a very simplistic web story. Now I have around 7-page web story ready with me for WebNext event, and if I want to see how it will look like in reality, let's click on the preview. Let me stop presenting and get this view for you. Okay, let's go to the preview section. So as you can see, I can choose in the preview which are the types of phone I want to like see this on, how this looks like. And this is exactly like happening. You are like, welcome to UINXT. You say why to attend. This is events agenda. You go through the agendas, and then you just introduce the speakers. So as you could see, like within minutes, we are ready with our uh, web story. Let me share the presentation back. Let me quickly do it. And here are my slides. So thanks for like sticking around and looking at this demo. So these are the resources that I wanted to share with you, which you could use to even connect with the people who are working behind this stories project. There are social channels which you can follow and like interact with. If you want to learn more about it, these are all the resources available. And finally, thanks a lot for being like the lovely audience and like joining my talk for today. And also the thanks to the UNX staff for hosting this amazing event. And don't forget to join me at the virtual booths and networking between 7 to 8 p.m. for any kind of questions and answer you may have around the web stories. Or you could just drop in even if you want to just say hi. So see you there. And don't forget to do cool things that matter. See you. Cheers. Bye-bye.
Thank you so much, Saurabh, for your insightful talk. Truly, accelerated web seems to be the technology of the future.
The smart lounge looks pretty cool too. I can use it to visualize my new home, how my new home might look like after all the furniture that gets in. This is simply amazing, and there are numerous possibilities. Of course, we may use it while moving to our office location when the pandemic ends. This is awesome. And again, guys, I'd like you to continue tweeting about our web conference so that it reaches a lot of people with a hashtag UINX. Amazing goodies wait for you.
Moving on, micro frontends is a buzzword for quite some time now, and I have heard my colleagues talk about how life can be compared to a collection of microservices. To take this philosophy further, we have with us the senior solution architect from MongoDB, a Google developer expert, and an Angular and web technology enthusiast. Please welcome Ms. Natalia Bendito.
Hello, everyone. Thank you for having me here. My name is Natalia Bendito. I'm a senior solutions architect with MongoDB, and I've been involved with user interfaces for 20 years. So from studying architecture to working as a graphic designer and then as a web designer, to being a self-taught web developer and software architect, with a focus in front end, by the way, in user interfaces. Right now, I am also part of the program Google Developer Experts in Web Technologies and Angular, and also part of the Women Tech Makers in Barcelona. I'm a Google Road to GDE mentor and an Azure Hero inclusive leader. And also recently I was awarded Microsoft Most Valuable Professional in developer technologies. So what I'm trying to do here, or what I'm going to do for the next, 30 minutes, is tell you about micro frontends, talk to you about architecture patterns, and maybe help you in the decision of using or not using this pattern, and if it's good for your use case. Let me start this talk by saying that for some reason, a lot of people think the work of a front-end developer or a front-end architect sometimes is really simple. Like, we are creating these amazing and seamless user experiences when coding interfaces and requesting data from here and there, from different origins, and putting it all together. And they think this is relatively straightforward, but it's not that simple at all. And to illustrate that for a while, I like to use this mind map in my talks. And I like to use it because it shows how front-end architects particularly are very concerned with user interfaces and user experience and the components that make it possible. But they also need to have a very, very good understanding and overview of the whole system they're working on, from the very infrastructure to the important integration patterns, the integrations of code to a code base or continuous integration, the front-end setup, the technologies involved, the best way to put all pieces together, knowledge on browser support constraints and strategies. They need to know about standards, specifications, about protocols, about APIs, about E2E testing. They need to be very knowledgeable on security, on authentication, on content policies, on headers, on how to prevent exploits, on how to better store data on the client side and sometimes on the backend. And needless to say, they need to know how to troubleshoot, how to debug, how to access sources, and how to make sure runtime performance is within budget, and how to preserve an impeccable UX experience. And this is all the components of creating a great user experience in the end, a great user interface that sometimes people forget at the time of choosing their next pattern. Sometimes we get attracted by trends or by hype, and we forget that we have to go over all those concepts, over all those concerns before we make decisions. And we have to go over all these again because architecture patterns, especially in the front end, translate into a good user experience for the end user. And also we need to make sure that we meet our client requirements. And we ideally want to do that in a way that allows us to create a balance between a great development experience for our teams and a great user experience. In trying to achieve this balance while tackling this complexity, we look for new frameworks. This is what we do a lot of the time, the front-end developers. We are very concerned for what's out and very stressed if we cannot learn it. And we want to integrate new tools and new patterns that will help. And one of those architecture patterns that's discussed a lot over and over and is on the table for a while now are micro frontends. So you probably have heard this word around a lot recently, and when we hear about a trendy architecture pattern, especially in the front end where we are very prone to experimenting, like I was saying, and adopting new ways of doing things, we can't help but wondering if this is the right solution for us, right? And the question has an answer that requires a lot of analysis, a lot of evaluation of your current state, and a lot of thinking of where we want to go. The first thing that we will weigh in, or that will have some impact in our decision, is if it is an existing application or it is a new application to be launched. Because if we try to convert to micro frontends an existing application, we will have to perform a migration, right, of the current implementation. And while we make sure that the current state continues to be operational, that continues to be serving a lot of users perhaps that are part of our ecosystem. So we don't want interruptions. And the most important question to ask ourselves is, do we really need this change? This is the first thing you need to ask yourself. Do we have problems? Everything is working perfectly. Why should we make any changes? What are the problems we are facing in the contrary case, in the case that we decide that we really need to take action because things are not going really well? What are those things that are not going really well? So let's focus more on this existing application example and what we would need to think of in case of a migration. This is more or less an accurate representation of most web applications, particularly large ones, maybe enterprise ones, with a bunch of stakeholders behind it and more than one cross-functional team working on it. Like we described before with the mind map, some may think that front-end developers only stay concerned and thinking about the UI components. But when we are talking about architecture decisions, the whole layer cake is a concern for us. So when the code base, the integrations and infrastructure that are part of this application becomes too massive, we usually know it by the name of monolith. And a lot of people are super quick to judge monoliths, but they are not always a bad solution. They're not always a solution that doesn't fit our use case. Monoliths usually and historically imply that all the code is coupled together. And if we put our focus in the front end, we will have a lot of HTML, a lot of CSS, a lot of JavaScript, or maybe TypeScript files, whatever you're using, all bundled together, but not necessarily output together. So monoliths usually rely on a single build process that gives teams the opportunity to keep dependencies in check and implement techniques for code optimization and performance, like leveraging to the maximum common assets and resources, executing code splitting and tree shaking. And there are other advantages. For example, at the time of implementing E2E testing strategies, is much easier if all your code, if everything, all your features are part of the same code base. So before HTTP2 and even HTTP3 right now, the norm was to aggregate all this front-end code to minimize requests and enhance performance. But that is no longer necessary. It's in the past for most cases. Even legacy systems that want to conform to web core vitals have updated and split the output right now. But it was true in the past. And although there were techniques to open multiple connections and pipelines, it was HTTP2 multiplexing that finally enabled us to execute effective modularization from compilation to output in a more performant and sophisticated way. And with that, we maximize the use of bundling tools to separate code and request only was necessary when it was necessary, right? And avoiding the transmission of data over the wire that won't cover anything. That's a metric I can share with you that most sites, most legacy sites, have up to 90% of code coverage, so 10% of code coverage for CSS, and the rest 90% is code that goes nowhere in and is not necessary. So this decoupling allowed us to explore the possibilities of clean code and code optimization more in depth. And we started decoupling not only components, but modules, and started packaging common code as libraries and consuming it from public registries like NPM. And examples of these are bundlings of all style abstracts, for example, so you can use them from different components. All JavaScript helper functions, for example, so you can also consume them from your components, because sometimes people think that, oh, libraries are things that some other third-party developer is publishing somewhere and I can make use of. But no, we can also leverage that in our day-to-day development or application lifecycle. We can extract, we can abstract things and publish them and consume them as an independent library. And of course, when you have a very, very aggressive abstraction, and when you consume from NPM heavily, and who doesn't, you will want to have a very, very well-designed static analysis strategy, a tool that helps you with that, so you're able to enforce code splitting, you're able to enforce tree shaking strategies. And tree shaking is essential to prevent bloating, to prevent having exports or imports that you don't really need in your application, that in the end up adding more kilobytes to the code that you send to the end user. But it demands good practices to support it. Like, for example, you have to avoid anonymous exports because then they cannot be shaken. And ever since Webpack 4, we have the ability to flag our modules when they are pure, when they can be safely pruned, and we can do that using the side effects property. So also in terms of front-end build strategies, by splitting code into chunks, we can improve the runtime performance by categorizing code, for example, and inlining requests that are above the fold. So they are there right away, and users have all the code, like the page is functional or the application is functional right from the millisecond zero, to splitting those components or those items that are going to be loaded below the fold and load them asynchronously or deferred. And then we guarantee that if they never scroll down, they are never downloading this code. But we were discussing the possibility of migrating an existing monolithic app to a micro frontend. And here what I'm going to do is I'm going to propose you something. Before we even think about moving to micro frontends or a micro frontends architecture with all that imply, all the costs, all the efforts, the first thing we need to do is optimize and decouple our monolith. So how do we decouple in the front end? The first step is to determine what are our goals. What are we trying to achieve? This is why I mentioned we need to establish what is causing us pain at the time of thinking I need something new. So some, but not all of the reasons why we feel a monolith is not effective is because we cannot reutilize code, because we have duplicates, because maintenance is a mess and scaling gets truncated. So let's start out optimization by fixing those issues. And we've seen before how we have tools and techniques right from the very compilation and bundling of code to categorize entities that are part of our front end and bundle them together to reutilize, like abstracts, like helpers. But there is also the possibility of reutilizing components themselves. And all we need to do is identifying in our UI those components that are used over and over and extract them to the most atomic unit that is part of the design, so we can reuse it. The first thing to do is think in terms of composition. So let's suppose we have this screen. The first exercise would be to separate containers from presentational components, right? And the second step would be to identify all those components that repeat over and over. For example, here we have 2 titles, we have 2 snippets of text, we have 2 call to action buttons, we have an image component and a video component, and we have icons, hence an icon component. And if we want to go really atomic, we could say that the label, even in the call to action, is a component in itself. So we could extract it to its own folder with its own files. Of course, maybe our client is going to give us a completely different specification and say something like this: I need a stage that has a title and has a snippet of text and a call to action, and I also need some sections in my page with a video teaser and a text teaser and a button, and I need a configuration menu button that has an icon. But we have to go farther in extracting atomic components, in analyzing what's in the page from those large blocks, and thinking of entities that can be reused again. So all CTAs are buttons and can share the same structure. All titles are headings, and you should be able to configure the HTML tags. All texts are the same, rich text editor probably in the background. All icons are put in place via the same mechanisms, and all images probably use the same structure and polyfills. So we can think of a single base and then compose, right? And this is the process of creating a components library, a library of parts that you can version, that you can maintain in smaller parts, and even discard those parts that you no longer need, right? And when you update one, you update all, because the problem is if you create a teaser component, for example, and the button is part of the structure of the teaser component, if the buttons change in the design for the whole website, you are going to have to update in multiple places. But if you have a components library, you only have to update things once, right? And maintain things once. So I 100% recommend you start here. And there are a couple of plug and play options. Component libraries out there that you can use, but remember that every additional third-party library comes with additional maintenance burden and costs. So now if we bring back this slide and we think of each one of those components that we were talking about as reusable modules, it all starts to make sense on how we can abstract dependencies and reuse code to compose interfaces. And now we know that with this pattern in mind, we can solve problems like code duplication. We can make maintenance a lot easier. We don't need to have code again for each one of the components repeatedly. We only maintain it once. I apologize. So you don't have code duplication anymore. You can reuse all the abstracts. You can enable mechanisms to easily restyle components using, for example, CSS variables. And everything gets simplified, even if you have a single team and a single build system or process. Now let's explore a more complex scenario. Let's take a look at this graphic and imagine this scenario when a lot of people are working in a project, right? And this is familiar to especially enterprise scale developers. Imagine we're a team during our sprint. We have this page or view with many components on it and services and stuff behind it, and only a few entities will be worked on this sprint. So maybe one is a full new feature, while two needs to have the JavaScript extended, and three needs to have new configurations coming from the backend. Typically, how you will do this is if we are working on a Git flow kind of strategy, is you will branch out from your base branch. It can be the develop or main or whatever you call it. And very likely, if it's a very large project, you will have independent teams working on each feature, and you will very likely open then a release branch from the default or the base. And then when everything is tested and ready, you will merge it and deploy it to production environment. The problem with these dynamics from a technical perspective is that every release triggers a new version for the whole system. So if we are again in the monolith architecture example, even if we have a components library where the components are versioned, you will have to rebuild the whole system and bump the version and redeploy. So one of the issues that teams were trying to find a solution for when breaking the code apart was the need for more independent release cycles for features. So they need to find a way to deploy independently. So you have a feature connected to a business domain, and this feature gets maintained, but the rest of the monolith maybe is kind of stable and doesn't need to be touched. Even though you are working on a single feature, you're going to have to rebuild and release the whole code base. So in the backend, what they did is they broke apart, they decoupled, and they solved this problem using a microservice architecture. So they split code into domains, and that really solved the deployability issue, although it needs a good team setup and dedicated processes to make it work. For this system to work, we should respect some principles, and the principle number one is the one of an independent team owning the feature and making sure their own architecture and process choices are respected, and there should be no shared logic. Every small part should be able to fail safely and silently without impacting the rest of the system. And basically, when the backend is decoupled, the most organic solution for the front end is also to break apart, right? It's not 100% necessary and guaranteed that it's going to be this way, but it's probably a good choice to maintain each one of these individual parts from backend to front end, all in the ownership of a single team that maps to a single business capability. Now, micro frontends can be implemented in different ways, and one of the aspects that will influence the technique the most is the level of encapsulation required. When the level of encapsulation required is very, very high, integration is safer from a security standpoint, but it is less performant. Since you cannot share cache styles, you cannot reuse fonts and other dependencies, and there is less opportunities then to collaborate between teams. It also becomes a black box in certain cases with respect to other parts of the system. And here I want to quickly show you what the different levels of encapsulation are for the different techniques that are more used or the most used for micro frontends. So hyperlinks have a very high level of encapsulation because you are loading different pages, while iframes is high, even if they are in the same context. ES imports are very low, and web components are in a medium kind of level, depending on the use of Shadow DOM. So for composition, you will need some sort of container to integrate your micro frontends, and what the kind of container will be will depend on the pattern you use or the technique you use. It will depend if those micro frontends coexist or not as part of the same code base. So if they're loaded in one single page, you probably will need something like a host or app shell to load them. We can think of this as the host, the runtime that will expose shared and vendor dependencies, as well as APIs for communication and state management. And apart from having a team that is in charge or that owns each one of these independent micro frontends, you will always have to think of a team that is in charge of the whole orchestration, of the whole putting together those micro frontends in this app shell. Now, all these scenarios we were discussing before, all these micro frontends were requested from the same origin. They were part of the same code base. They were deployed to the same ecosystem. So basically, you still have the chance to integrate them in your unique build system if you wanted and run static analysis. But what if we had the case of a micro frontend application that was not hosted in the same context? Imagine the scenario where a part of your application is developed by a third-party team, deployed independently in a completely different domain, but still needs to be integrated. We can do that, and we have been doing this with iframes for ages, but there was no way to optimize the code, and there was no way to share dependencies. This was before Module Federation came to existence, and it was released in the last quarter of 2020. So Module Federation can finally allow us to do or run static analysis and share dependencies between remote applications, a thing that we could not do before. So let's go back to this example we've seen before. What Module Federation will allow us to do is that even if each one of those independent pieces are part of a different context or domain, it will allow us to integrate them together from those remote scopes. And how it does this is by assigning roles to each one of those parts. We have a role assigned to the host and we have a role assigned to the remotes. And the only difference, because these roles are interchangeable, is that the host is going to be always the scope that is initialized in the first place. So in this example, each application is bundled independently with a certain configuration and host in a different origin or domain than the host. So we will need to make sure to configure a few things. Let's start by the host. Obviously, we need to be on Webpack 5 in order to use Module Federation, and we need to require the plugin. And what's important here is that we need to give a scope name to our remotes. We can alias them in the remote declaration, but just remember that this is a JavaScript variable and all the JavaScript variable naming conventions will apply. So here we see how we give the global name to one of our remotes as remote1, and then we can access it as window.remote1. We can alias it, like said, but the scope name needs to match the one configured in the remote itself. We can also, like said, declare what dependencies we want to share between the host and the remote. Now, share components have a number of advanced options, but the more you configure, the less likely they're going to satisfy those configurations, and maybe then you don't have so much dependencies shared. Now, let's go and configure the remote. The very first important definition is the public path, because otherwise all the files will be resolved from the root of the host and not of the remote. And if we pay attention to the exposes property, module is the public name for this remote, and remote.module.ts is the internal request in the mechanism. So the file name remote entry.js is not the bundle itself. It's configurable. This is the default. It's the loader. This is the loading script that activates the whole mechanism of requesting the code from the remote and checking the share scope, verifying the versions, making sure there is a certain definition for them, and then consuming this share scope or share dependencies both from the remote container and from the host container. So once you expose your module, you can dynamically load it to your application like you load any internal module. Like, for example, if we are coding in React, like we can see here, we can lazy load, we can use lazy and suspense to load this module as if it was one of the modules that are part of our code base. Exactly in the same way, if it was Angular or if it was Vue, we would use exactly the same mechanisms we use to import an internal module to our application from this remote context. So you probably also want a mechanism to either manually register or dynamically discover these remote modules. You don't want to be updating the configuration manually every time, because that would be an absolute burden to do. This is great, right? So many opportunities. We can either decouple, create component libraries, or we can really go in the path of micro frontends, and we can assign different parts of our application to different teams and make sure that we deploy and or have independent deployability for each one of those parts. Or we can even right now have the completely remote, owned by third-party modules imported in our application like they were part of our code base, and even perform static analysis and even reuse dependencies or share dependencies. So these are real great features that we can take advantage of. But we need to make sure that we have a great orchestration, a great composition strategy, that we have taken care of the routing, that we have good communication between components. Before we even make those moves, we need to design all this part of the system, all this layer above that will allow us to have consistent user interface, and that every component really seems seamlessly part of the user interface and not just something that we patch there, that we put there that doesn't really connect with anything else. Because the idea of having independent teams and deciding their stack and deploying on their own schedule sounds super appealing and almost perfect. There is no vendor lockdown. There is no getting stuck or trapped by a framework when it gets obsolete. You don't have to migrate the whole monolith, but you have to make sure that the problems you're solving are not smaller than the problems you are creating. Because every layer of abstraction you combine makes it more difficult to achieve great results. And we know, for example, every framework has a different flavor for state management, and state management nowadays is very, very important. Most applications do have a state, especially if they have users. So one mechanism we could use to simplify communication between components and even have some ephemeral state handling is an event-based publication and subscription bus, leveraging client-side storage methods like cookies or local storage. You can also trigger API calls to persist state server-side on events. And there are many lightweight libraries that help you with this. Or you can also go ahead and use browser inbuilt mechanisms like using window.postMessage event. And finally, to wrap up, APIs in the front end are going to definitely keep you busy if you move to a micro front-end strategy. For state management, for communication, for orchestration, you will need them to consume data as well. But remember that systems are a whole, and there are other services coming from the backend as well that you are aware of consuming as APIs, then as a coupled part of the component. So a microparts architecture demands that you clean up and that you maybe refactor your whole code base, that you get rid of redundancies, that you lower down the total cost of ownership of this system by using tools that are designed and invest money to increment features and tie all the knots and don't have to spend so much time maintaining lower level features. For example, if you have authentication in your application, you shouldn't probably be maintaining the code that makes it possible. You should probably be using a third-party service as an API. And migrating the architecture patterns may be a good trigger to simplify the architecture as a whole, and leveraging cloud infrastructures and serverless options. Front-end developers can support their own backend needs right now by writing functions in languages they're familiar with, like TypeScript or Node, and setting up GraphQL servers in minutes in the cloud in a couple of clicks. They can also use webhooks via HTTP or cloud services to respond to events in the backend. And databases in the cloud, especially those with more flexible models like MongoDB, for example, enable the consumption and modification of data without needing complex ORMs, layers, and anything else that really need a great investment of time. So this type of infrastructure is ideal to support a microservices/micro frontends model. And to complete the talk, I brought a simple module federation demo. I think I'm over the time, so I'm going to very, very quickly show it so you can see how you can bring remotes. Even locally, you can have several servers running on different domains or on different ports, and you can integrate it all together and use publication and subscription to communicate between those. So I'm going to change. I'm going to stop sharing. Let me move things away a bit. And now I'm going to share this very, very, very quickly. I hope it's being seen. This is an application that is, it's a vanilla JavaScript application. It's just an HTML page. You can see over here all the elements. We can see here that we have several sections. I don't know if it's big enough that people can see. We have several app shells over here. So here what I have is an application, an Angular application that is integrated over here as an iframe, right? And then I have over here another component that is an Angular standalone web component, right? And you can see that it's brought, or it's requesting this remote entry. We can see it here in the network. The remote entry over here is then requesting the actual, not here, this one is requesting the actual element that is going to insert in the page. So again, this is not requesting the code, it's a loader that allows all these scopes running together and communicating between each other. And if you take a look at how it works, is basically this component is going to trigger the scrolling of the other application. This is because they are communicating via post message, window.post message, and this is very simple development, but allows me that if I am the team working on this component and I want to make changes, I want to bump the version, or there is a bug. For example, over here I have another component that is also integrated in the same way, and it's broken at the moment. So if I wanted to bump the version, I wanted to fix this component, I wanted to re-release it, and I wanted to integrate it, I could do it without having to impact the whole application. And this is the main goal of micro frontends, to have independent pieces that are independently deployable, that you can work on their own. Like over here, we can see, for example, the code that bootstraps all this together. This is, by the way, in my GitHub. You can use it to experiment with module federation. And what it's doing is allowing this host listener to listen to the messages coming from the other application in order to scroll. Finally, make sure that if you have this strategy in mind, if you're going to deploy code to production without being known by the other teams, that there is a good integration and testing strategy, because in the end, the ones that have to benefit from this are the end users, and they need seamless integrations, and they need great user experiences built for them. Thank you very much.
Thank you so much, Natalia, for expanding our horizons in such interesting tools and technologies.
In the teaser also you saw how robotics is this amazing field which makes us wonder if all our Iron Man related fantasies can turn into reality. It is something we can all try our hands on. Also, don't forget to keep tweeting with hashtag UINXT to win amazing goodies from our sides. And stay tuned for our virtual booths where you'll get to know more about these technologies and these projects that we are showcasing in our teasers.
So moving on to a very enthralling talk about domainization of Angular. This is domain-driven design with Angular by none other than Slobodan Gajic. Slobodan is a JavaScript developer at Multilogin, a content creator and an educator. Please welcome Slobodan.
Hello, welcome to today's presentation. Here we're going to discuss how to implement domain-driven design with Angular. It's technology agnostic design pattern, but Today, I'm going to show you how to do it. Angular can do that with other frameworks and libraries. But before we start, I would just like to give a couple of sentences about myself. So my name is Slobodan, and I'm a senior front-end developer at Multilogin. Previously, I worked for companies like TopTel, Freelancer.com, and also I had projects in big companies like Microsoft as well. In my free time, I like to create some educational content, and also I'm an educator. I like to create tutorials. So if you're up to learning anything about front-end, feel free to check out my LinkedIn profile and also YouTube. I'm sure there will be some useful stuff for both studies and some experienced developers as well. And apart from technology, I'm a big sports fan. I like playing sports, watching sports. Also, I like to travel. I like fishing. I like photography, videography. So if you're up to any of these, feel free to ping me. I'm always to friendly chat and we can discuss that. So now let's head over to presentation. I would like to start my presentation with a quote. So if a just were an Olympic sport, India would be assured of a gold medal. And this is a quote from Veena Venugopal. She's a published author, and she's speaking about the position of mother-in-law in India's society. But what she's trying to say with this quote is basically that Indian people were able to adjust throughout the history whatever got to them. So if we are able to use the same attribute and apply when designing a system, we can say that we design a good software system, right? Something which will be able to adjust to last long, like for 10, 15, 20 years, if not more. So something that will scale and be able to be maintained easily and to adjust, because we are in ever-changing industry and everything is changing every 6 years, 7 years, 10 years. It's totally different from what we have been creating at the beginning. So, but how do we come up with a good software system design? We can, assure that not every system design is good, as if you can see on this slide, that some designs are easy to develop, but that they don't serve the purpose. It's easy to develop. If you ask me, in order to get a good system design, you need a group of experts. Some group of experts who have great experience in real-life scenarios, and they also have great technical knowledge. Why experience, you may ask? Because they know what works in real-case scenarios. So they apply, they experience, and they create best patterns, best practices. And with best practices, they come up with design patterns. And multiple design patterns actually lead to methodology. So what is domain-driven design? It's a methodology. And it was introduced by 2003 by Eric Evans in his domain-driven design book. He didn't introduce something new here, but he just gathered the experience by himself and other experienced developers, so created a methodology. And the main thing which domain-driven design is trying to do is to reduce the gap between the complex software development and complex systems and the business logic. That's all it's trying to do. So to break down the complex systems, which is hard to understand, overwhelming, and also it's very, very hard to maintain and adjust to the needs of the industry, like we mentioned on the first slide. So the main concept is to build long-lasting software system. And this approach is similar to what are using the big companies. It's like monorepo approach, which are using Facebook, Google, Microsoft for years, and it has been proven that it works correctly. So it offers two approaches, two disciplines. First one is tactical, and the second one is strategic design. Today, we're going to cover more strategic design, but the tactical approach focuses more on object-oriented patterns and how do you structure your code and some design patterns inside of your code base. Whereas strategic design focuses more on trying to solve what you see on this picture. So something which is overwhelming, too complex, which is hard to break down to understand, and especially with industry, like I mentioned a couple of times already, it's evolving, it's changing, and it's really hard to maintain. So it breaks down the complex software system into smaller pieces, rather called domains in this case. So basically, domain is easy. It's like when you're trying to solve a hard problem, you're doing data structures and algorithms, for example, and you break it down into smaller, easier pieces, and you see that actually the hardest problems are made of the easiest problem, just large number of easiest problem. And once you start solving the easiest problem, it's really easy to tackle the hardest problem. So like I said, today we're focusing more on strategic design. What is the main goal of strategic design? The main goal is to identify domains. So inside of a complex software system, you're talking about big complex software system. You're not talking about small applications here. So as software developers, oftentimes are not very familiar with the application, the industry of the application that they're working on. For example, you're working on sales, maybe on marketing, maybe on sports, and you not necessarily should know what is this about. So you need to work with domain experts in order to identify what are the domains in this industry, in this application, and to help you to separate them into logical pieces, smaller, maintainable, and easier, like I said, to develop, to understand. Then we are going to talk about ubiquitous language. What is ubiquitous language? It's basically same language, same terminology between the software developers and the business experts. So as you can see in this image, the business logic needs to reflect what is on the code base. So naming conventions of the methods, properties, classes, objects, everything inside of your code base needs to reflect completely what the business logic is about. Why is this the case? So once you start discussing that with your users, with business experts who are requesting the software, you need to be on the same page with them. You need to come down with the same terminology, methodology, and especially when application starts scaling and when it starts to be more complex. If you have different terminology, different words, because the perspective of software developer oftentimes is totally different because you're technically a versatile person who maybe users are not. So you have different terminology here. You need to be on the same page, and that's crucial, especially on complex systems. So I'm gonna show you an example. Here we have e-procurement system, and you can see we have multiple steps in this system, and I'm gonna try to explain you how, and you can see on an example, how we can split this multi-step process, which contains basically multiple domains, but here it's a one system. So we're gonna try to break it down into small domains. As you can see, it's similar as if you're working in a company and you're trying to order some new product that you need. Maybe you need a new laptop. The old one is broken and you need a new one. So basically, employee first requests a product. Then an expert needs to specify an order. So what is the quantity? What is the supplier? What is the budget? I mean, what is the price of the product itself? Then a manager needs to approve the order itself. You have the buying agent, it sends the order. Manager who is requesting the budget. So for that product itself. And at the end, we have an approval of a budget, and that's it. So as you can see from all of these steps, we have some of the steps which resolves more around the managers, about the budget, about the order specifications. And on the other hand, some of these steps do revolve more around the employees itself. So it can give us some idea how we can break down our system. I mean, that's crucial here. So the first and the main thing is catalog. It's the same thing as you want to buy something on your own, not in a company, let's say. You go to eBay, Amazon, or any other website, basically. And you can see what kind of products they have, what are the prices, pictures, descriptions, reviews, all this information. So it's a catalog. That's absolutely necessary, right? Then we have specification. This is a specification of the order itself. Like I said, the quantity, the supplier, the prices, and similar. Then we have approval, because everything because you're not buying here for yourself, this is inside of the company, you need approval for your manager. Do you really need a new laptop, or the old one is still working correctly? So, you need to have approval. And the last thing is the ordering. So the shipping, the ordering, all of these things. Now, let's take a look at one of these specific domains, which is a catalog. And if you look at the catalog, we have a model product. So like I mentioned before, once you want to decide, do you want to buy this product or not, you need a couple of information. You need the price, obviously, to see is it expensive. You need a picture to see, do you like it or not. You want to see the reviews of other users. Is it nice or not? Or what features does it have? Description is also very important. Like I said, it can have all the necessary information for the product itself, and obviously the title. How can you find what you need? So these all informations are completely necessary inside of the catalog, right, to make this decision. But if we look at this model inside of the approval domain, we can see that we don't need all this information. So we just need the price because it's related to budget. And are we breaking the budget or not? We need a title to identify an ID, obviously, to find the same product, the same model. So as you can see from this, the same model is not the same in the different domains. It's totally different, as we want to have the models which are as concrete as possible. And this is called bounded context. So bounded context means that we are not trying to create models that can explain everything and that provide unnecessary information in domains that we don't need. So it basically it leads to misleading, ambiguity, and misunderstanding. That's what we want to avoid. So here, context really matters. And let me show you a simple example what I mean by that. If you look at these two pictures, and especially at the red one, so if you're fighting with somebody, maybe on the street or in the office in this case, you can easily end up in jail. But if you fight in a boxing ring, and it's Olympics, let's say, you can win a medal or championship belt or a lot of money. So you're fighting in both these cases. But where are you fighting does matter. Context does matter. So it's the same thing with model. Model is only valid inside its own domain, and fighting is only valid inside of the ring, right? Okay, so we want domains to be separated as they can be. So unique pieces. But if they are only separated and they don't interact with each other, they are not part of the same system, right? So they need to interact to form a system. And in this case, we can see that ordering is communicating with catalog and ERP system. So basically, but the thing which we want to avoid, if you remember the picture from the beginning, where it's really complex, all these cables, right? So we want to give only access to the domains that we really need, and not everything inside of those domains. We only want to provide an access to the specific properties and methods that are completely necessary for ordering in order to do its function. So we are providing that with an API. Catalog is providing API to ordering. So ordering can only access the completely necessary information from catalog domain. And in this case, ordering has complete necessary information in order to deliver what it needs. And is in this example, ordering doesn't affect too much of ERP system. Then it's only provided with anti-corruption layer in order to access it. And this approach is called context mapping. What context mapping means, it's basically a way how to communicate between domains, and it allows us to only access the necessary information from other domains, and it restricts access to unnecessary domains and the properties and methods. So if we are able to access everything inside of it, in every domain, then we haven't separated anything. Then it's just like one system, and that's it. So these are the main concepts of strategic design. And we just scratched the surface here. But I would highly encourage you to go through all the things. I mean, I will recommend at the end the book for deeper understanding these concepts. But these are the key things. So let me just conclude what we discussed about strategic design before we move on to implementation itself. So we discussed about ubiquitous language, which means that software developers need to have the same terminology with business experts, right? So there is no any ambiguity between them. We talked about bounded context, which basically means that the model is only valid inside of its own domain. You remember the fight, right? It's only valid inside the ring. And at the end, we discussed context mapping, which gives us way how to communicate between domains, because we want to restrict access to only domains that we need properties from and methods from, and only give access to the things that we actually need, not to everything, because we don't need everything, you know. So only things which we need. Now, let's discuss how we can implement strategic design with NX. So in Angular, obviously. So what is NX? NX is an extension of Angular CLI. And apart from other things, NX can give us a way how to separate our system into application and libraries inside of one repo, which, like I said, I mentioned this previously. It resembles the mono-repo design patterns, and large companies are using this design, and it has been shown that it works greatly. Although this is just one approach, you can use some different approaches to implement strategic design in Angular. And the alternative approach is micro-app approach, which means that every single domain is a separate application. So you would need to create a separate application for every single domain in order to create this design system. But here we're going to discuss how we can do that inside of one application. So one of the benefits of implementing strategic design with NX is that everything is in one apps folder. So communication between them and maintainability is much easier when you have everything inside of one folder. Also, all domains are grouped inside of the ellipse, which stands for libraries. everything inside of one folder. So what are the benefits from this, you may ask? The main benefit is prevents version conflicts. Imagine like if you have 10 or 15 domains, and every single domain has its own packages, its own node module files. Imagine what is the complexity of dealing with all of these versions. So it's really hard to maintain. But no matter how many libraries, how many domains you have here, you have only one node modules file. Imagine that every single application has Angular CLI and Angular version, and you need to make sure that everything is in sync. Here, you can do only with one node modules, and you're good to go. That's it. So the good thing about NX is that it's a CLI, command line tool. And it's really easy. You just need to learn a couple of commands, and you're in a good position to work with it. So in order to install the NX, you just run the command npm install -g, which means that you're installing globally on your machine, and then the name of the package itself. And this is the name for the NX. If you want to create a workspace, it's really easy. You would just run the command create NX workspace and then the name of the workspace itself. And here, the name is eProc for e-procurement system. And in this example, I'm going to show you the example from the beginning of the slideshow. Now, to create apps and libraries inside of your project, it's really easy. So first you need to cd change directory to your workspace, and now run the command cd eproc, and that's you're now inside of your workspace. And now you need to run ng generate. Now, so in order to generate applications and libraries, it's completely the same command, except you're adding app argument, and for the libraries you're adding lib argument, and that's it. Now after that goes the name of the library and the name of the application. So ng generate app UI, it's the name of the app, and ng generate lib, which is the library, and the name of the library itself. So feature request product. Now NX gives us multiple categories in order to keep us separated and layers inside of our domains, so that everything is structured and organized. So we are not allowed ourselves to do organization itself. So now let's see what kind of categories we do have inside of the libraries. So we have first feature category, which is for complex and smart components. This is the logic of the components. Then we have UIs, which are basically called dumb components. They are reusable parts of UI, obviously. Then we have data access, and most of the components actually can access, especially the feature components, can access data access categories, because they provide access to HTTP and WebSockets. Then we have util categories. Util category is especially something which most of the domains and libraries can access util category, and the util category is a helper category. So it contains all the helper functions for calculating. So you're avoiding duplicating your code with this category. Then most of our applications have multiple domains, obviously. Otherwise, we are not going to use this system. So the shell is providing us with the access point for multiple domains. So it's deciding the application what to choose when they're starting the application. API, as if you remember previously, we need to provide a way and to provide the methods and the properties that you want to expose to different domains. So API is providing access point to other domains in order to access what they need inside of other domains. And remember, libraries can only access the libraries inside its own domain, and they can only access the things that API is providing to them. And that's it. Now, domain is providing some specific logic to the domain itself. Like in our previous example, it's providing, for example, some additional expenses, and you can store that logic inside of this category. Now, as I mentioned just a couple minutes before, libraries can only access the libraries inside of its own domain. So, but not everything, not everything inside of every library. So this, especially if you're building a lot of libraries, it can be a little bit overwhelming, and you can start thinking what can be connected and accessed from one library to another. So NX is us providing a way how to check this graphical representation and to see what actually we can access from which library. So you can do this and run just the command npm run deep graph, and you will get the graphical representation of what library has access to which library. As you can see from this picture, this is something that you will get once you run that command inside of your CLI. As you can see on top, it's a little bit overwhelming at start, but let's break it down. At the top, you have UI library. Basically, it has access to catalog shell. As I mentioned before, shell is providing us an entry point to the application. And it has access to features or feature libraries. Feature libraries has access along with catalog API to data access category. And everything combined has access to the utils category, which are like helper functions. So NX is providing us way how to approach the other libraries and domains and also restrictions. And it's doing that with a couple of things. So first thing is it's doing that with TSLint files. So if you try to access the library which is not inside of your domain, you will get an error. Not only from the TSLint JSON file, but also from NX JSON file. So they're prepending with the scope different domains. So like you can see here, scope catalog, scope share, scope ordering. So they are predefining their domains with a name so that you're only restricted to use those libraries and nothing else. And this is really simple way of creating this with NX. And that's it. So we come to a conclusion that implementing strategic design and domain-driven design with NX, it's really easy using NX. So let's just conclude what we discussed today. We discussed what domain-driven design is and what it's trying to solve, what problem it's trying to solve. Also, we discussed strategic design. We talked a little bit about tactical design, but we didn't have time to cover that. And also for strategic design, we only covered a key concept. There are a lot more, and you should look at domain-driven design as a toolbox. And there's a lot of tools inside of this toolbox, and I would highly suggest that you should learn everything to go through all this methodology and choose the things which you need for your project. You will choose, like with any other library or a framework, you're choosing only the things that you need for your project. And also at the end, we looked how to implement everything with NX. At the end, I would highly suggest if you can find the printable copy of Domain-Driven Design from Eric Evans from 2003. Maybe there were some later books, but I highly suggest that you read everything and you will be much better architect. And that's all from me for today. I hope you learned something new, and stay safe, stay well, and I see you in some other occasions.
Thank you so much, Lobodan, for your perceptive talk. Clearly, domain seems to be a solution to a lot of our technological problems.
So again, are you looking for a lightweight, energy efficient, and a super fast way to communicate between IoT devices? To the rescue, here's MQTT with its built-in feature like topic-based PubSub, QoS, Last Will, Testament, and much more. Moving forward, don't forget to tweet a lot with the hashtag UINXT. Stay with us. Stay tuned till 7 to 8. We'll be opening a Q&A session for all the virtual booths that you have been seeing.
Coming up next is an interesting talk about WebAssembly, taking you back to the basics of binary instruction format and further. The next speaker's name is Federico Carregui. He's a computer systems engineer and he's now in his 8th year at Globant. mostly in Uruguay, but also in India, where he worked in Pune a couple of years ago. He's been working with systems for over 30 years since last century, and his focus is on agile development, mostly for the web, including front and back end work. So please welcome Federico Kerecki.
Hello there. My name is Federico Kerecki. I am a computer systems engineer from Uruguay, and I have been working as a subject matter expert here in Globant for this is my 8th year. Today, I will be talking about something old that is suddenly new again, WebAssembly. Let me consider the problem we may having. Are web pages, web applications too slow? We have to discuss 5 questions for this. Do we really have a need for more speed? Is it a real problem? Can we do things differently? What can be this new and old solution? What is WebAssembly and also assembly script? And what is coming in the future? Those are the 5 questions I want to address in this talk. And let's go with the first, quick. Why do we need more speed? The reason is that today we are having web apps that do work that previously was reserved for desktop applications only. For example, we are processing video, virtual reality, augmented reality. We are doing artificial intelligence work like machine learning. We are doing 3D graphics, advanced gaming, numerical computing. All these kinds of things are CPU intensive, and yes, they need more speed. So how can we do better? Can we work in a different way? Yes, the answer is yes, we can work in a different way. So what are our main concepts? Native applications are certainly faster, but they have some inconvenience. For example, they need installation, and there are way too many environments, Linux, Windows, Macintosh, maybe mobile browsers, mobile code like Android, iOS, all those. That's a sort of problem. So here comes the good idea. Why don't we run code in a virtual environment using assembly language as its machine code and compile those good fast languages we like to that code? This is our different idea. And wait a moment. This is really a new thing. The past is calling, because I started working a long time ago. So we not so long ago, the 50s, but we are talking about using assembly code like everybody used assembler in the 50s, and we are speaking about using a compiler to compile our code like we did with Fortran in the early 60s, and maybe use a stack-based language like Forth in the 70s. That's not so new. We have seen it before. Let's go a bit back to some memories from the past century. Interesting picture of myself when I started to work. Look, I look almost practically the same. I was slimmer back then, but let me take you to the past, a lot of years ago. In the past, we had microcomputers like the Apple II in the picture, based on the 6502 8-bit CPU. when you worked with those machines, assembly code, machine code was needed and quite relevant. I do remember specifically that at one time I had to write for myself a driver to be able to print mathematical symbols, Greek letters for the texts I was preparing for the university where I taught. So I use assembly language to do this driver and work with an Epson matrix printer. It worked very well. And in those times, we had languages very fast, very small, like Forth. You didn't have a lot of memory. You didn't have very fast CPUs. So things had to be efficient. And I used Forth that ran almost at machine code level of speed. And I used it to learn structured programming and even program my own Moonlander arcade game. Back to this century. What's our new old solution? The new old solution is called WebAssembly. What is WebAssembly? WebAssembly is now considered to be the fourth web language after HTML, CSS, and JavaScript, obviously. WebAssembly has a binary instruction format. It works with a virtual machine that is stack-based and really is a compilation target. We'll more about this later. And the applications we write with WebAssembly run in a sandbox, the same as the browser, with near native speed. So we are running code in a different way in the same browser at a high speed. By the way, what I told you, this is WebAssembly. This is not really meant for you and me to directly use it. And it certainly is not for all kinds of tasks. We are considering WebAssembly as a compilation target for compilers. So you do not really want to write WebAssembly by hand. Not the best idea. Rather, you will write in some high-level language, and that will get compiled to WebAssembly. Also, it's not for common input-output oriented tasks. We really want to use it for CPU-intensive work, like we mentioned earlier, virtual reality, machine learning, whatever, because those are the use cases that really benefit from that. For common web pages, really, it doesn't matter. And this WebAssembly, you will notice some of the users really fall into that category. TensorFlow for artificial intelligence, Unity for games, AutoCAD for design, Google Earth, Google Map, Lights. So all of those are CPU-intensive work. We can, for that kind of thing, we can see that WebAssembly is really speeding. In these charts for Chrome and Firefox, blue short lines are better than long pink ones. You see that WebAssembly practically always manages to beat the pink. There is only one case in which it didn't. So WebAssembly, it seems that it really has a performance advantage. And it's supported everywhere. Okay. Everywhere as usual for web developers, meaning everywhere except Internet Explorer, as usual. You have in Chrome since March 4 years ago, and Opera, Firefox, Safari, Edge, all of those support WebAssembly. You will have to set something else apart from Internet Explorer. So we have a new idea, a new way of writing code, faster code, code you can run in your browser, in most browsers, Let me show you a real life example. I will talk about an actual case you can use yourself on the web. Computer chess. If you are into computer chess, you have probably heard of Stockfish. Stockfish is at the top of chess engines, or at least it was until AlphaZero from Google, but that's not really important now. As a chess player, Stockfish is rated with an ELO level of over 3,550. That's a way to rate players. Carlsen, the human champion of the world, is only 2,850. So you will notice that computer chess is way above human players. This Stockfish was written in C++, and then if you wanted to run it on your own machine, you had to have a specific version. But it so happens that the Stockfish developers adapted the code so it could be compiled to WebAssembly. Once you have this compiled version, you can download it from the browser, and then you can have Stockfish running at almost native speed, providing complete functionality without any installation. And you can see it here. This is a game I was playing, and I am doing analysis. You can see there that Stockfish is running on my local machine at full speed and looking 25 moves ahead, far more than I can manage. So all that without any kind of installation. So I have a native speed program running locally, no installation, in my browser. That's right. But as usual, not everything comes up as roses. Not everything is perfect. For example, let's see some questions you may have at this time. Does WebAssembly run separately in its own virtual machine? Answer, no. It shares runtime with the browser. It's not a separate thing. It's part of the virtual machine. Does it run directly on the CPU? No, it doesn't. It's a virtual code, so it needs compilation or interpretation. It doesn't really run natively. It has an extra thin layer in it. Does it use threads? Maybe, because it depends on the browser and the version. Not all browsers, not all versions support threads. So you may have problems if your code would benefit highly from threads. Then it may not be so universal. And a few more things. It has no DOM access. You cannot directly interact with the web page. No multi-threading now, as I said. It has no garbage collection. JavaScript has full garbage collection. If you want to handle dynamic memory, you have to do it yourself. A very nice source for programming errors. There may be some browser differences according to the involving security aspects. And if you thought that JavaScript web pages debugging was hard, you haven't seen anything yet. Debugging WebAssembly is way harder than that. How do you get started? Suppose you want to get started with that. What can we do? Okay, it's not very complex. This diagram shows all the steps. First, you have to develop your code in C, C++, Go, Rust. There are several languages that you can use for that. you have to write the code in a special way. It's not directly any C++ code will run, anything in Rust will run. You have to adjust it a bit. You have to follow some conventions, use some libraries, whatever. This sort of things is expected. But you write your source code in a high-level language. Then you compile it to WebAssembly. When you are using JavaScript on your web page, you have to import your code as a WebAssembly module. That's important. And from that point on, you can just instantiate it and use it. The WebAssembly code becomes a part of your program. If you define the functions in it, you can call them, they will return values, you can use them, so everything is very nice. Should you be curious about the code that was generated, there is an extra WebAssembly text format. You see it at the bottom for readability. That's in case you want to learn or see the code specifically, then you can do that. So using WebAssembly requires some extra steps, and you are working in a different language. This may be not what you wanted. So there is one other thing we can do. There is a better way for JavaScript developers. We are going to meet a faster JavaScript, assembly script. What is assembly script? Okay, assembly script is a strict variant of TypeScript, meaning it works, it looks the same way, but there are some differences in semantics. Some operators are not exactly the same. There is no big differences, but you have to learn them. Also, the language is totally typed. You have no dynamic features, so you can do ahead of time compiling. So at every moment, the compiler has to know exactly what's the type of your expressions, of your variables. And the negative side, obviously, assembly script is being developed, so it's not so mature as language. It doesn't have such a lot of documentations, users, and support as more classical languages like C++ or even modern languages like Rust, which are very popular. What feature do we have in this assembly script? First, it's JavaScript-like. It has a JavaScript-like library, so you are using the same kind of functions. You have static typing. You have to be used to defining types as in TypeScript, but that's no big deal. It does memory management for you. So what I mentioned, that WebAssembly did not have its own memory management, assembly script provides this for you. It has garbage collection, and the key thing, very easy JavaScript interoperation, meaning you can call JavaScript from assembly script and assembly script from JavaScript. Both can call each other, so you are really mixing in assembly script as if it were plain common JavaScript. Wait a minute. There are some missing features, obviously. If you are very knowledgeable about TypeScript, you know any and undefined values. You do not have it. You cannot define any type. You are lacking at this time private and public variables. Regular expressions, even if you like them too much, you won't have them here. Closures, a common JavaScript feature. Iterators, you do not have it. You do not have REST arguments. You do not have exceptions. You do not have promises. So at this time, WebAssembly used through assembly script is very speedy, but you do not have full JavaScript compatibility for your code. You have to restrict yourself a bit. You may say that for CPU intensive tasks, this may not be so meaningful. For example, promises are mostly used with I/O. That's not CPU intensive. So maybe if you do not have promises, you will not care about that. It depends on your code. We have come this far talking about what we have in assembly script. I won't try to give you an example at this moment, and I won't try to make this talk into a course of assembly script. I will provide some links at the end for that. But if you are interested in this new language, in this new feature, let me get a look ahead. Where are we going from here? What are the future plans? There are some very interesting questions. The first question most people say, will assembly script replace JavaScript? Answer, most unlikely. It's a complement rather than a replacement, meant for a different kind of problem, and it has a lot of restrictions. If you wanted to do a very simple, chat page using WebAssembly and AssemblyScript, you would find several problems, and it would be much harder than need be. And it really doesn't match the kind of application you really want to use WebAssembly for. So it will never replace JavaScript. It's very unlikely, but it will be a complement, something extra for you to use. Will WebAssembly tooling get better? That's a high yes, undoubtedly, because it's a fact that today using WebAssembly is just too hard. And will WebAssembly and AssemblyScript become more powerful? Well, for sure. Its development is very important. There are a lot of people working on it, so you can be quite sure that features like threading, exceptions, types, and more are being considered. So I wouldn't be surprised if in a short while AssemblyScript reaches a sort of parity with JavaScript as to its features. Okay, we have gone through a new old solution, WebAssembly. We have mentioned a tool you can use for that, AssemblyScript. I hope your curiosity was piqued by this, and sorry, but it's time to leave. Thank you for being here, and I will leave you with some recommended reading. See you.
Thank you, Federico. It's always good to attend such an insightful talk from someone who is not just passionate about technologies, but also carry with them a very rich technology experience.
In the teaser, you saw how IoT-based solution for precise location detection and pushing tailor-made notification works. I'm seriously looking forward to it and using it someday. Going forward, we have our 7 to 8 virtual booths, which we have been talking a lot about throughout our event. So please stay tuned and please use these booths to know more and get more knowledge about all the innovative ideas that we have been talking about.
Okay. And don't forget again to tweet with hashtag UINXT, and we'll be giving you amazing goodies for that. For tomorrow, we have lined up yet another exciting event packed with innovative talks, so don't miss it for the world.
Because innovation, we can do it all day.
Hello, everyone. Welcome back to the second day of UINXT. I am Parijat Sardesai. I am a technical director for the UI Engineering Studio. Hello, everyone. Welcome back to the second day of UINXT. I am Parijat Sardesai. I am a technical director for the UI Engineering Studio at Globant. Hope you have enjoyed attending the digital avatar of UINXT. The show is still on till tomorrow evening. By now, you would have realized that UINXT is not a web conference which talks about only web or mobile development, right? But how the landscape of UI has evolved, solving some real world problems or challenges. One such problem hit all of us when the pandemic struck us, right? We all went remote, and which made the collaboration between our teams really cumbersome. Some months ago, while recruiting new talent at Globant, we actually struggled with different online code editors who we wanted to use to do a collaborative approach while conducting online interviews. And thus we started wondering about a reliable platform that can help us solve this problem. And then we realized that one of our technology partners, JetBrains, already built such a striking platform that could be leveraged not only for online collaborations, but also for pair programming to become more efficient. So without further ado, I will introduce you to the speakers for the day to walk us through it. Ekaterina, she is a product marketing manager at JetBrains. And Matt Ellis, he's a developer advocate at JetBrains. Over to you, Kate.
Hi everyone. I hope everyone can see us and our presentation. It's a great pleasure to be here. And today we're gonna talk about Code With Me story, how we came up with this product idea, and then share some inner secrets. And after all, we will have some Q&A session. So feel free to use our chat to post your questions. And I'm passing my word to Matt.
Hello, everyone. Thank you for joining. We're going to talk about Code With Me and what's going on there. So let's dive in and get started. If you're not already familiar with Code With Me, it's a fairly new product which has been introduced with the JetBrains tools. It's a collaborative editing tool for nearly all of our IDEs. There's only a couple which we're not supporting right now, and that is Rider, and I'll explain a little bit more about that as we go through. And also, we've just introduced an early bird version for Android Studio. Other than that, it's available for all of our IDEs. Excuse me. It was introduced at the start of the year. It was bundled with the 2021.1 releases. So if you've got a recent version of an IDE, you can get started right now. You can just click the link and click the button on the toolbar and get started and get working collaboratively. What it does is a pair programming tool. So it allows you to work together on the same code base, together working sort of side by side in the same code, and you get all the great features you'd expect from an IDE tool, a JetBrains IDE, such as the obviously syntax highlighting, but things like rich navigation, code completion, inspections, quick fixes, and so on. But it's not just about the programming, it's the full development lifecycle as well. So there's debugging available in there, testing as well, so you can both do this sort of wherever you're working. And there's also audio chat, video chat, and even screen share as well, so you can see what you're working on. The idea is to give you absolutely really rich IDE functionality and ideally the entire feature set of the IDE. So we're working very hard on bringing that to you. But it's not just about pair programming. It's much more than that. You can have up to 100 guests in a session. So you can sort of do like a mob programming kind of idea. You can get the whole team involved to work on a particular solution. But this opens up a whole bunch of different sort of scenarios. So as well as getting your team in to work on a problem, you can do things like mentoring or teaching. So I could lead a session and I could take you through a code base and explain things to you. So I could teach new concepts or teach a code base. You could also use it for code reviews, for example, where you can actually review the code in the IDE, where you've got all the tooling available to you to navigate around and even fix issues that come up as part of the review there. It's a great way of working. A number of scenarios that are available is massive, really. So it's whatever you want to do to work together collaboratively on there. Some of the key things that go into Code With Me there is that the guest requires nothing. So we don't expect the guest to have an IDE installed already. You can go to a clean machine and you don't have to have a source checkout. You don't have to have the code set up. All of your build processes run already. You don't have to have any compilers in there. You can have a clean machine and just click a link and get started. All that happens is that you download a lightweight, thin client there. Once you click the link, it gets downloaded for you, starts up the session, and you're good to go. So if you're not familiar with Code With Me, let's jump straight into a quick demo. I've got a copy of the IDE here on the left of the screen with just a simple project going on. I'm going to show it with a Kotlin project in IntelliJ IDEA, but Code With Me works with all of the IDEs and all of the different languages that the IDE support. So if you're using RubyMine for Ruby or PHP Storm or Golang for Go, then it'll work with all of those, and you just get all the same sort of features. I'm just showing it with a Kotlin based project because it's something I've got to hand. Getting started is very easy. We have a Code With Me button in the toolbar. You click that, you get a few options there. I can do enable access and copy invitation link. And this dialog here gives you a couple of options. Just quickly to look at this here, these are important. There's some permissions that you can have. We can have a read-only permission so that any guest who joins in will be able to view the files but not edit them. You give them the ability to edit files, and you can have full access or even a custom, which is a mixture of things. We've got some extra permissions that can be available here. So we could hide some files if you've got some things in there, so some configuration files with secret keys in, for example. You can access the terminal as well, so that you can allow guests to run command line actions. Obviously, there's a small amount of risk in there. You need to be able to trust that the people are going to do something sensible there. So you can actually change that from being full access to view only. When it's full access, you get to see exactly what's being typed and run on your own machine there. So that's okay. And we have access then to run and debug and other tool windows as well. From here, you can automatically start a voice call as well. So you can do the audio and video calls too. So you just click the enable access. We create a link. It tells us it's copied to the clipboard. We would send that to your colleague, and they would be able to join and jump in. I'm going to do it all on one machine here. I'm going to have myself pairing with myself there. I'm going to paste the link into a browser. That's already going to download the client for me. It's going to start everything up, and we're good to go. The way it works that I'm going to show you right now is we're going to have the host on the left side of the screen there in the light theme, and then the guest joining is going to be in the dark theme on the right. Now, this dialog is very important. It's a bit of a security feature we've got here. All of the traffic between the two parties or the people within the session is encrypted. It's end-to-end encrypted. To make sure that there are no sort of man-in-the-middle attacks there, we've got these security codes which you can verify on either end there. If the value is the same on both, then you can actually, know that everything is encrypted and safe and good to go. And now you can see on the right-hand side, we've got our guest who's joined the session there, and we've got a little notification on the host window machine there. And the guest immediately gets their own view of the project, and we can expand these files here. We can see that there are all the files that you'd expect to be able to see, just like you can see them on the host itself. I've got all the features that you might expect there, so I can just start typing field and navigate to the field class. Once I'm in here, I can look at all the members that are in there and sort of very quickly navigate around. Is the game ended? and jump there. Let's just hide that so we can see that a bit better. And you can see I've got all the features you'd expect from a rich IDE there. I've got code folding, so I can collapse those down. I've got syntax highlighting. I can control click and navigate around. I can do find usages on that there, and that will go off and see where that's being used and show me my list of usages with previews here. And again, nicely sort of grouped, like you'd expect, showing where the value is being read, showing where the value is being written, features like that. And if I wanted to start typing, then I can just start typing, and I'm going to get code completion. What makes it more fun is that I can do the same on the host, and I can see that the changes have already been made across there. And in fact, if I select that, the guest sees exactly where what I've got selected. So let's say, let's just clear that. And if I'm going to start typing it here, this is from the host. You can see that it's immediately sort of copied over to the guest as well. And the guest can join in and say, this is from the guest. And so we've got the collaborative editing kind of thing that you're working on here. It's important to point out that the guest, it doesn't have anything installed on their machine. They're using the same files that the host has got. And so you're actually working on the host's file itself. You're editing the host's file there. It's not just Kotlin files. We can quickly jump to HTML file. And there we go. We get to see syntax highlighting with HTML. And there are some inspections here as well. So if I scroll down here, we've got this image tag, which should show me a pop-up. I'm not getting the wee tooltip for some reason, but you can see in the status bar there that it's saying the missing required alt attributes. I can hit alt enter and it'll insert it for me. And I can say, this is my alt attribute. And so I can do the usual sort of quick fixes and inspections and things that you'd expect from a rich IDE. I mean, you can see up at the top here, we've got all the list of the problems that are available the IDE has found in this particular file here. And so you can step through those and work through those and get going. I want to show a very quick overview of Code With Me. So let's just look at a couple of other things we can show you here. We've got a Code With Me toolbar here, and this is the voice chat we've got enabled. We've got voice and video. Unfortunately, because I'm presenting, I can't show the camera there. Let's see what happens if I try and start that. Oh no, it is going to work. There we go. So I can have lots of copies of me on the screen at once, waving at myself, which is nice. And we can also do a simple text chat as well. So I can do, hello from host. And then that appears there as a wee pop-up in the guest as well. And we can switch over to the host on the, there it is, on the guest, and we get to see there, and I can reply back very easily there. So we can have text chat, voice chat, and also if we have a look at these things here, port forwarding as well, which is very useful if you want to sort of test an application that's being run on the host machine. So one last thing I want to show you before we switch back is the idea of follow modes. Follow modes is really useful because it can be quite easy to lose place of where the other people in the session are. And so you can actually follow them and see where they are right now. So I can go and see where the host is and click jump to, and it'll take me straight there. I can also do this follow mode. And now if I'm the host, wherever I go, then the guest will follow me. And so if I go and even if I go to a separate tool window, then it can follow me there and it can see where I am and that's great for both keeping track of where you are in a session, but also for scenarios such as a code review or a mentoring session and so on. And these follow modes are really, really useful and a great way of working. And they're easy enough to stop as well. And I can just go off and do some work as well. So perhaps the guest here could be writing some tests while my host is writing some code. There's lots of interesting things we can do. Right, so let me just now leave the session here, and I'm going to switch back to my presentation. So that's a really very, very quick demo of what Code With Me can do. I could talk for the whole hour really about the features that it's got and how it works and so on, but we want to have a look at some of the things which are a bit more behind the scenes and so on. Just to note though, if you've already used Code With Me the start of this year, we've had a new release out, 2021.2. We're currently working on the 0.3 release. As the 0.2, there's some nice new features that we've got there. We're continually improving what we've got there. We've added screen sharing in and port forwarding, which is great if you want to see what's happening with an app that's being built on the host, or if you want to be able to run the application yourself. We can do port forwarding over the connection there and run and access applications on the host. We've added a couple of new tool windows with Python packages and the Python console as well. And we've also got our early bird version for Android Studio, and it's now bundled with app code. And of course, some technical improvements under the covers as well. As I say, there's a lot more things that we could talk about, we could show you here, but a couple of useful links there. If you want to go to the short link, jb.gg/CWM for Code With Me, then there's help pages there, which are fantastic, set of documentation, some videos, and we've got some other webinars as well, where we've taken people through stuff on JetBrains.tv. Okay, so that's an idea of what the product actually is. Let's have a look at some of the ideas behind the scenes. What is it? Why did we build this? Where did it come from? What's the sort of technical background to some of this? And I think to look at that, really, we have to kind of go back a little bit in time and have a look at some of the history and really kind of ask ourselves, how did we get here? And if you're not familiar with what JetBrains does, we build IDEs. We've got development environments for pretty much all of the mainstream languages that there are. IntelliJ IDEA for Java and Kotlin, Golang for Go, CLion for C++, PyCharm for Python, PHP Storm, RubyMine, WebStorm for web technologies, and so on. Excuse me. About 5 or so years ago, we decided that we wanted to build a new IDE, which was Rider. We wanted to build a .NET IDE. This is an IDE that we built, and it sort of first came out in the start of 2017. We were working on it for a little bit longer than that. Rider is very important, very interesting, because it's the first IDE we built that's actually made up of multiple processes. What I mean by this is, if we have a look at some of the other products that we've got, you can see how these are made up. So if you're already familiar with our .NET offerings, you might know about ReSharper. ReSharper is a plugin to Visual Studio, which gives all of the rich IDE features that you know and love from JetBrains IDEs, but inside Visual Studio for .NET code. We've also got IntelliJ, which is the platform we use to build all of these IDEs. So all those IDEs I showed you before, Golang, PHP, Storm, PyCharm, and so on, they're all built on a common platform, this IntelliJ platform. So when we came to build Rider, we had an interesting dilemma. We've got this ReSharper code base, which we've been building for about 11 years, and it's got a ton of great functionality, loads of really cool features, and we'd like to reuse that and make use of that, not have to rewrite that at all. And we've also got this IntelliJ platform for building IDEs, which is likewise, we've been building that for about 14 years at that time. So we've got lots of great functionality there as well. So it'd be great if we could put them all together. But the problem is, ReSharper is a .NET application and IntelliJ is a JVM application. And so they don't really kind of fit together nicely. But we didn't want to rewrite those kinds of things. So we kind of did the only thing we possibly could do, and we made it a multi-process IDE. So what we do now instead is that we have IntelliJ providing us all with the platform for providing IDE features, but all of the language features themselves are provided by ReSharper running as a separate process. And so we had to sort of have some inter-process communication there to work with that. This gave us a few really useful benefits. So for example, we could reuse those existing code bases, and meant that Rider, when it very first released, had a lot of great functionality there. For a version 1 product as it was, really, it's had a load of really useful features because it's based on IntelliJ and ReSharper. But another really useful feature is the fact that we've pushed this language support out to a separate process. The user interface is in one process, the language support is in another. We've kind of got this client-server architecture, and it means we can avoid doing work on the UI thread. We do that anyway, but we need, it means that there is even less work going on the UI thread. It also means that we can reduce the amount of memory pressure. So as we're working, obviously we're allocating memory, we're running garbage collections, and that's going to be happening as we're doing language processing. But we've also got a very interactive application, and the more garbage collections we have in an interactive application, the more you'll notice that as the UI can stall, can stop, can pause. And so we kind of end up with better, improving our throughput, and that actually gives us better performance there. So pushing all the processing out of process turns out to be a useful scenario. But we had an interesting question here again as to how do we do this inter-process communication? We've got these two processes, we've got the user interface, and we've got the language support. How does that work? We had a number of options. We had looked at a lot of different things we could have done, but the question really kind of came down to what style of communication do we want? Do we want something which is remote procedure call based, sort of request, response, or do we want something where you've kind of got shared state? So it's a stateful connection and you just update the state when things change. And there's lots of pros and cons to this kind of approach, these two different approaches. And so we had some principles really for why we wanted to do this, what we wanted to get out of our inter-process communication. And they kind of boil down to these things really. So we have we wanted the communication to be lightweight with some very simple serialization. So if we think of RPC, which is request and response, one example of that where it's being used in with language support as it is the language server protocol. You may already be familiar with this. It's a JSON-based remote procedure call based protocol. So you send a JSON request, you get a JSON response. That's heavier than we wanted. That's got overhead. It's a text-based format with overhead, and you're going to have to deserialize it and reserialize it and so on. And we're expecting to do a lot of communication across this this pipe. So we kind of need to have something which is very simple. So JSON doesn't really fit in our plans there. We also want something to be easy to extend and evolve. We're going to keep on working on our IDEs and on the language support, and we want it to be able to evolve with the features that we implement. And again, if we look at the language server protocol, then that has a very currently a fixed set of features which don't match everything that ReSharper and IntelliJ can do. And so we'd have to extend that protocol, and that's fine. It's an extensible protocol, but it becomes a question of how much do we want to extend a protocol and continually extend it before it's not worth it. Perhaps it would be better if we just had our own protocol where we didn't have to have lots of extensions on top of it. But another really key issue is that we want two-way communication here, bidirectional communication. So we're working in a kind of client-server style where the all the language processing is happening in ReSharper, and it's the server, and normally all the information is passed from the client to the server. So you hit a key, that gets notified to the server, and something happens in response to that. But occasionally things want to go the other way as well. So for example, if we're doing inspections, we want to show all the highlights that are in a file, you don't want to be continually asking the server, do you have any inspections? Do you have any inspections? Do you have any inspections? You want the server to tell you that kind of information. And so we want the data to be able to come back to you. And using a JSON-based, RPC-based protocol makes that a little harder. And so taking all these things in mind, we decided to build our own protocol, and we came up with the RD protocol, which is the reactive distributed protocol. And this is a mostly stateful protocol there. We synchronize data between the front end and the back end, the client and the server there. It also allows for RPC style tasks there, so we kind of get the best of both worlds, really. We get two different ways of working, which is nice. So we can use the approach which works best for a particular scenario. It's a socket-based binary protocol, so it's very lightweight and it's very straightforward, and it's socket-based, which makes which is going to come up again later, really, basically. And it's open source. If you want to have a look at it, it's on GitHub in the JetBrains/RD repo. We've got support for C# for the JVM, so Kotlin or Java, and also for C++ as well. So we can actually work with a few different platforms going forward. It's based on a Kotlin DSL, a domain-specific language, which describes the format that we want to pass data across. And we use this DSL then to generate serialization code. So this is very, very efficient. If I want to pass a number, a string, and a number, then the serialization becomes write number, write string, write number. If I want to read it, it's read number, read string, read number. It's very simple. There's no reflection going on there. There's no parsing of string-based files and so on. It's very simple and very accurate. The flip side to that is that it implies that we have tightly coupled versioning. If I want to change it from number, string, number to number, 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 string, number, then obviously both sides have to change. For Rider, this isn't a problem because we ship the product as a whole thing. And so that's not caused us any issues with Rider, but it's something to remember. The protocol also has some conflict resolution built in as well. So the values on the protocol can be versioned effectively, and whoever has the highest version there can win, and it works sort of appropriately like that. So, excuse me. Right, so I've mentioned that this is a sort of stateful protocol, and it's all about synchronizing data between the ReSharper language support and the IntelliJ front end. But what data am I talking about here? We talk really about what we call view models, and the idea here again is to be sort of really lightweight. So we don't want to send lots and lots of data over this communication here. We only want to show to send just the data that's important for presenting the information. All of the processing happens in the ReSharper side in the ReSharper process, and then we use the IntelliJ process to display the results. And so we only need to show that presentation data. If we think of inspections, for example, the only data we really need is the severity, the tooltip, and the text range. So if I've got my squiggly in my editor, I need to know whether that's going to be an error, a warning, or a suggestion. I want to know what text I'm going to show when I hover the mouse over it, and where it is that I want to apply that. That's just 3 bits of data per inspection. If I want to do that for an entire file, it's just a list of those 3 things. So it's very lightweight and very easy then to pass the data backwards and forwards. We can do the same for the Alt-Enter menu. So if you hit Alt-Enter to try and fix an issue, we need to pass over the ID of what's going to be drawn in the menu to... it's important to point out, sorry, if you hit Alt-Enter, then you have to ask ReSharper out of process what to display, what menu item is going to be there. ReSharper will calculate them and return them back, and it shows an ID of what it is that's going to be invoked if you choose that menu, a text to display, an icon display, and then whether or not there's going to be a sub-menu there. So again, very lightweight presentation data, which is quick and easy to pass backwards and forwards. We can do the same with dialogues as well, though. If you've got a refactoring dialogue, if I'm going to rename a field, for example, I can very easily create a view model which describes the dialogue. There's got a text field in there. This text field has to be a valid identifier, and we can actually use that then as part of our view. The data is also hierarchical. This is really quite important and very it's very fundamental to how we structure everything there. It's hierarchical in both its structure and its shape, but also its lifetime. So if we imagine opening up a solution, a project there, that solution is going to have multiple open editors, open files. And each editor is going to have a list of inspections, the squigglies that are on the text there. And that is basically just going to be a list of our inspection view models, the severity, the tooltip, the text range, those 3 items. And you can see there's a hierarchy there. If I close that editor, then I expect all those inspections to go away as well. And so the lifetime of these objects, this hierarchical then there is sorry, the lifetime of these objects is also hierarchical. And the protocol we've got has support for this kind of lifetime management. And the other key thing is that it is observable. And so the whole model is made up of observable properties and collections. And whenever you make a change to the data, it's synchronized from both sides. So that if I make a change in the host, that change gets copied across to the client, and the client can subscribe to changes. So if I have my list of inspections, my squigglies, then if I add something into that list, I get notified that something has been added, and I can update that list as part of the editor squiggles. If something gets removed from the list there, I get notified and I can remove it from the document as well. And it's important to know that it's observable on both sides. So I can push data from the client, or I can push data from the server. So that's kind of a bit of an overview, really, of what we've got with Rider there, and it's worked very well. And Rider's very successful and works nicely, and we've got a lot of benefit from having this out of process model here. But then there's kind of an obvious evolution there. Once we got to a certain point with Rider and we proved it and it worked and it was successful, we kind of started to ask a couple of questions, really. The first one was, what if the client and the server are actually on different machines? It's a socket-based binary protocol. That socket doesn't have to be on the same machine. So we could do something a bit interesting with that. And then the second question is, well, what if there were multiple clients? We've got a client-server application. We've got one server, but we could have multiple clients. And that led us really to collaborative development. It was one of the oldest and most highly voted issues we've had for a long time. And we decided that we would take this on as a challenge from what we've learned with Rider and applying that then into collaborative development. And that then leads us really to Code with Me. And that leads us to what I've just shown you there with Code with Me. And we can see really that the architecture for Code with Me is pretty much the same conceptually as what we have with Rider. So we have IntelliJ as our host. And this is not just IntelliJ IDEA, but any IDE that we've got. So it could be Golang, it could be WebStorm, it could be PHP Storm. And then we've got the Code with Me client using the RD protocol over our binary socket, connecting as a client to the server. Yes, which is what this slide just says there. So yeah, the host IDE is the server, and it can be any IDE, and the guests are all just the clients. Now, the client itself is interesting because the thin client is effectively an IntelliJ-based IDE. So it's using the IntelliJ platform to give us all the framework that we normally have for working with IDEs. So we've got the editor, we've got the tool windows, we've got the same user interface, we've got the alt enter and so on. But it's stripped down. We've pulled out all of the sort of fat client features that we've got in Rider. So Rider makes use of a lot of the IntelliJ platform to provide other interesting things. So there's a lot of indexing. So it indexes the project you've got to be able to do the find in path, for example. There's no language support. Rider has web tooling, which is taken from WebStorm. So it has web language support in it. There's no version control system. That's been taken out of the Code with Me thin client there as well. So we've got a very stripped down IntelliJ-based IDE, which doesn't really do very much other than talk to the Code with Me server. But because it's the IntelliJ IDE, it's customizable. It can have its own settings, its own themes. So for example, the demo I was showing you there, we'd switch that theme into the dark theme, but you can download plugins which give you more themes, different key maps, and things like that. Some plugins don't work with Code with Me, so it makes things a little more interesting. If you wanted to use a plugin to provide different language support, for example, say you wanted a plugin that's going to provide useful features for a HTML or JavaScript library, then that's not going to work because all of the processing for languages happens on the host. So if you try and put something on the client which will do that, it's not going to help. It's not going to do anything. But the flip side to that is that if the host has that plugin, because it's doing all the language processing there, and the client just picks all that up, the client gets that plugin effectively for free because the host is using it. So it's a really interesting and rich model. Another key thing with the Code With Me client is that it is universal. So it is the same client can be used with any host IDE there. So it is a client to connect to a server, and it can be used with any IDE there. The Code With Me stuff is built into our IntelliJ platform, and we can use that and reuse that for any of the IDEs. You don't have to add in specific support for it. And the clients themselves can just connect to that and work with that. So, for example, if we're doing inspections again, we've got those 3 items there, which is the severity, the tooltip text, and the text location. Then that's going to work no matter what language you're working with. It's just going to work based on the files you've got open. So all features come from the host. So these inspections will come down from the host. And again, it implies that all processing is done on the host. And so the host is the truth. The host is the server. The host owns everything. The host owns the file system. So it's fine. And that means that the Code With Me client really is a kind of thin client. But we're using the RD protocol, which is our binary socket-based protocol. And if you remember when we talk about Rider, that requires binary compatibility. So if I change the format there, the serialization won't work. And so we've got that constraint with Code With Me as well. The version of the client must match the version of the host. And again, this isn't necessarily a problem because it all happens seamlessly. You click a link, we know what version you're supposed to be using there. We will download that client, cache it, and use it for you automatically. If the host updates to a new version, then when they send you a link next, we'll see that it's a different version and very quickly download this lightweight client, cache that, and use that instead. So there are some problems, or rather challenges, I guess, with this approach and what we've gone there. The first one really is multiple users. IntelliJ was not designed to be used by multiple users. It's designed as an application that sits on your desktop. You sit there with one keyboard and type. So it hasn't been designed to work with having multiple people editing simultaneously, editing the same files, editing multiple files, and so on. So we've had to build a number of interesting features into this, a lot of infrastructure and frameworks to work with that. So we support simultaneous editing and the conflict resolution, just like when you're working with Google Docs and there's several of you typing at the same time. We do a very similar thing there. It's not quite the same, it works slightly differently, but it's the same basic idea there. We have this sort of event sourcing idea. We keep a list of the events that are about to happen, and we sort of synchronize that between the guest and the host. And the host is, of course, the truth. And so you have to apply those actions one by one on the host. And if it changes, you have to notify, and there's conflicts, you have to notify the other guests that are involved so that they can resolve those kinds of issues there. And we have to synchronize things like text content. So yes, the text that you've actually typed, but also the location of the cursor of the caret, also the current selection, and things like action availability. The host must be in a good, consistent state to be able to invoke an Alt-Enter action. If you hit Alt-Enter, it has to know what the code is before it can do something with it. But the good news is that that's all working. It's all in there and working nicely. And we've built all of this conflict resolution on top of our RD protocol, and it's working very nicely. Another interesting problem has been dialogues and tool windows. And there are a couple of different problems with this. Firstly, we need to be able to show dialogues and tool windows to guests, but also there are different constraints on different tool windows and different dialogues. So for example, if I'm showing the project view tool window, I don't necessarily need to see the same project view that another person in the session sees. We want to have the different tree nodes expanded or collapsed and so on. But if I'm using something like the terminal, where I can run any command on the host machine, everybody should see the same thing. And so we want to be able to have different instances of the tool windows for different users. And sometimes we want the same instance of the tool window shared across all the different users. So there's been a couple of different constraints there. The way of solving these are pretty much the same same way as working there, and it's basically creating more view models. We add more view models into the protocol there, and that describes what's going on there. It describes the tree in the problem in the project view. It describes the text that you see in the console, and it works very nicely. We get to effectively remote this information over to the clients. We also have a technology which we've written as part of Rider, actually called B controls, back-end controls. So these are user interface controls that we can use from the back end, from the server, and have it displayed on the client, on the guest. So I can write some code which describes a bunch of controls, and that dialogue will effectively get the description of what that dialogue is gets passed over the protocol, and the guest can read that from the protocol and draw it back out again as a proper dialogue. And that's a great way of working there. We can effectively write a UI like you'd normally write a UI, just using a slightly different API, and that would then get we can run that locally if you're running something like Rider or IntelliJ as it is, or it can run on a guest as well. Another issue is how all of this works with threading. IntelliJ is a massively multi-threaded application. We do a lot of things in different threads and running things on background threads. A good example here is code completion. So the client starts completion and notifies the host, which starts processing on the main thread. The notification comes in on the main thread, and so it starts work there. It moves to a background thread to complete the processing, and once it's complete, then it moves back to the main thread to send the response, but it doesn't know who to send it to. It needs to track the client throughout all of that in order to be able to know who to reply back to. And we do this by passing the client ID through the code base. We've got a bunch of APIs to do that. So that was an interesting sort of exercise in changing APIs to work with that. The next kind of thing is the internet. So if we were thinking about Rider, the sockets that we've got working on there, they're on the same machine. So we didn't have any problems with things like connectivity going away or latency and so on. But with Code with Me, we can't rely on a permanent connection there. So we need to be able to have automatic reconnection. And we also need to resync the state there. So if things fall down and you want to reconnect, then we need to make sure that all the state gets resynchronized. Fortunately, that kind of happens. That's almost built into the protocol because it's all about synchronizing state. So you just resync the state and we're good. With connections, we want peer-to-peer if possible. And if not, then we need to still be able to support that. And therefore, we have some relay servers. And all of the data there is sort of end-to-end encrypted as well. So we've had to build extra layers on top of things here, and also infrastructure. We want geographically distributed servers to sort of work well with latency and connection speeds. Speaking of connectivity, we've got 3 different types of connections. We've got 2 direct connections. If you're sitting in the same office, we can probably just do a direct socket connection and use that. Otherwise, we can try a Google's Quick protocol, which can punch through sort of some of the NAT traversal type stuff. And finally, we've got our relay servers there, which will send a message to our relay server and send it back down to the guest. We start these 3 connections at the same time, and whichever one has the best sort of ping rate is what we will use. So a quick rundown then really of the components we've got that make up the infrastructure for Code with Me. We've got the lobby server. This is responsible for generating the link and joining sessions there. You generate a link, it gets sent back to the host, you send that over chat and the guest joins. We have the relay server, which you just mentioned there. If we can send the messages up to the relay server and back down to the guest to work around issues with connectivity. We need some sort of local storage there, so you can download something which you can use to download your clients. The thin client needs to be served there. It's usually handled by either by the lobby server or another web server. And then we have telephony, so our audio chat, our video chat, video conferencing, and that uses the Jitsi framework. So we didn't really build our own system here. We made use of the fantastic Jitsi framework. It's an open source platform. It's very widely used, very actively developed. Lots of corporations use it and contribute to it. And we have some infrastructure around that to be able to create the sessions and join them. So as part of this infrastructure, we have to host some servers, lobby and relay servers, and also a little bit of telephony infrastructure to pass the details onto the client, to set things up and pass it on to the client. And it's important to point out we've got the Code With Me Enterprise version as well, which allows you to run all of this infrastructure on your own network. So you can have this if you want to have total control of the conversation that's happening between the colleagues. You can have that there if you're on an isolated network. If it's company policy that you don't use other people's servers, then we've got a solution there where you can host all the infrastructure yourself. Okay, so let's wrap up then. What next then? So we've kind of had a look at where it came from with Rider, where we are right now with Code With Me, and what next? And it kind of comes back to this question again, really. What if the client and server are on different machines? And that's what we're looking at right now with remote development. It's the next evolution of Code With Me there. It's allows you to run your development environment remotely, and you connect to that via essentially the same protocol that we've been using for Code With Me. And you can kind of view it conceptually as a single user Code With Me session. So it's like if you were just using a normal version of IntelliJ or Golang or WebStorm to work with your project. But instead of it being all locally on your machine, or everything is running on a remote machine. So there are lots of great scenarios that this will work with there. So you can work with a known clean development environment. So you set up once and clone it. Everybody is working with the same environment very quickly. The development environment includes the IDE. You can have the project built and indexed, and so it's instant on, very quick to get up and running with a new project, rather than having to clone everything, index everything, build everything, and so on. Switching branches becomes trivial. You just switch to a new environment. And you can create a repro scenario if you're trying to fix a bug just by creating an environment, set it up, clone it, and share it with other people. Again, we've got different challenges going on here as well. So you're going to have building the environments as well, lots of different types of environments we can use. We are creating a warm-up mode. So this allows us to run the IntelliJ host, the server effectively, to build the project, to get the indexes all done, and then shut down so that you can then have a clean environment ready to go. We also have another challenge there of needing to support all the dialogues and tool windows, not just some of them which make sense for Code With Me, Code With Me for a collaborative session, but everything, things like project settings in there. And there's going to be sort of several approaches for that. View models, again, will be the favorite one there. Our B controls are a great way of doing it, so we can rewrite some of our dialogues to use B controls. And we've also got a new version of B controls coming, which can take a look at existing JVM swing-based controls and automatically generate a view model for those, which is fantastic. We also got a thing called Projector as well. So if things are really complicated, we can use Projector, which is a great project which JetBrains wrote, which takes the underlying graphics of a swing-based application and sends it over the wire to somebody else. So as far as the code is concerned, it's just using normal swing-based APIs to build a UI, but then it can be displayed on a remote machine. So that's where we're heading with this. We're looking at sort of remote development as a scenario here. And that really kind of brings me to the end of what I wanted to talk about. We've had a quick look at what Code With Me is. We had a quick demo there. We've seen where it's come from with Rider and the protocol and the constraints that led us to working with what we've got there, what we have now with Code With Me, and where we're going to with remote development in the future. So I just want to say thank you for watching. We've got a link there again, jb.gg/CWM for more information. If you've got a later version of the IDE, the button is there ready to go. So just click it and give it a go and try out Code with Me. And then I think really it's a case of, do we have any questions?
Yes, we do. Thank you, Matt, for this fascinating talk. Even though I know everything, every time I hear, hearing another presentation is so much fun. Let's see what we have among questions. And yeah, I like this one. Any specific reason for opting C++ as a language to build Code with Me?
So C++ isn't the main language for Code with Me. So we use, I think the primary language really is Kotlin. A lot of the, because Code with Me is based on the IntelliJ platform, IntelliJ itself is a JVM application, so it is mostly built in Java. We've been building it for 20 years. It just had its 20th anniversary last month, I think it was. So it's a mainly Java application. A lot of it's in Kotlin now as well, but it's JVM. And so the majority of Code with Me is also JVM based, and it's Kotlin. The team prefer Kotlin as it happens. The code which is working with Rider, again, the IntelliJ side of things are going to be Kotlin based, but that's in C# on the ReSharper side of things. But we've also got C++ libraries for the RD protocol so that we can actually use it in more native scenarios as well.
Okay, thank you. The next question is, what about offline support? I believe that we partly covered it, but could you please repeat how does Code with Me work offline?
In what kind of a scenario? As in collaborative editing? We actually require you to be online for this, basically. So if you are if you're the host, then obviously everything is just working fine for you there because it's your machine. But unless you're online, you can't bring other participants in. You can't create a session and they can't be in because they need to be working on a different machine. So if you want to be using pair programming offline, you have to do the old-fashioned sitting next to each other with sharing a keyboard.
Which might be not really available right now.
No, not quite.
Actually, when I first saw this question, I was mainly referring to working in behind the firewall.
Yeah.
It's also kind of offline situation.
Absolutely, yeah. So yeah, if you've got an isolated network, for example, if you've got your own sort of private network within a company and you don't have access to JetBrains servers, for example, then we do have this Code with Me Enterprise version, which allows you to host all of our infrastructure in your own network there. You can set it up and configure it how you want. It can be geographically distributed if you want to. You can have it set up to not talk to the outside world at all, and you can have all the functionality there from downloading clients, starting sessions to the relay server, and also you can set up telephony as well using the Jitsi framework.
Okay, we have another question. Are companies using it for conducting coding tests like many other contemporary tools? How do you put safeguards to make sure people are not cheating while coding?
That's a really good question.
That's the perfect question.
Yeah. How do you stop people from cheating? There's nothing built into Code with Me itself for that. So Code with Me is a collaborative tool, and you get to work together there. There's a certain element of trust that needs to go on there. Although there's permissions involved with things like the terminal, for example. You don't have to give everybody access to the terminal or to all the files to work there. But one thing you could do, I guess, we've got the audio chat and the video chat. If you are doing a test there, you can have the webcam up and have a face-to-face conversation while you're doing that, and then you can I guess tell whether people are cheating as such.
Yeah,
but there's there's nothing built into the platform.
Yeah, but I think that the whole idea having this real-time collaborative tool like eliminates this risk to minimum, because you can ask your partner to do something and you can actually see it immediately how he or she is doing it. So feel free to use it. But actually, our team is using Code with Me for interviewing. So we are like exploiting it on a regular basis. I think we have one more question, and this will cover the following case. Can we have individual groups as well for collaboration, like we have 100 people who can join us as individuals respectively?
I'm not sure I follow that one.
Yeah, I would assume whether Code with Me allows to host like big groups. Like, is it possible to create a session where you have up to 100 participants?
Yes, definitely. So when we're describing Code with Me, it's very easy to call it a collaborative tool, and it's very easy for people to say, pair programming. And pair programming kind of makes you think, well, there's two people there, it's a pair. But yes, Code with Me supports up to 100 people in a session there. And that might be a bit busy for a full coding session. So that sort of scenario might be more suited to a mentoring kind of scenario where you're taking somebody through a code base. I'm explaining an API or a technique or something, or I'm trying to show people how it works like that. But yes, you can have up to 100 people there. We can do mob programming. So it's great to be able to get a team of people in to try and solve a particular problem there. So not just two people.
Okay.
So, Kate, I can't stop myself. I jumped in to ask one of my favorite questions. I think which I mentioned in the beginning. Any plans to make Code with Me a client as web-based online editing tool? I have this from YouTube itself that a typical use case of having web-based would be to conduct online interviews. So any plans of making it a web-based availability tool?
Do you want to take that, Kate, or shall I jump in?
Well, I think, Matt, I will probably need a hand here because I haven't heard about such plans.
Yeah, so no, as far as I'm aware, we don't have any plans on that. The idea really with Code with Me is that the thin client, while it's a thin client, it still gives a lot of functionality there. So it's a very rich editor and a lot of tool windows and features like this. So it is still a very heavy is the wrong word, but it is still a very interactive application there. It's still making a lot of use of the user interface, and it's a lot going on there with dialogues and with tool windows and so on, that making it into a web-based tool is it would be a lot of work, and it probably wouldn't work as well as having the rich functionality that's in the thin client already.
Yeah, to sum up, the whole idea behind Code with Me is to provide users of JetBrains IDEs with the best collaborative tool. So that's why it's designed this way.
Mm-hmm.
Oh, okay. Fair enough. I thought I would ask my pain point with you. So, any other questions we have? I think that's all. We have a couple of more. Sorry, I have one question here which says that if we need to share the locally running development server, is it possible to do so? I mean, can we share React applications running on localhost 8080 port?
Yes, you should be able to do that. So we, in the last release 2021.2, we added port forwarding. So you should then be able to set up a port on the host, which is then going to get forwarded through the thin client, basically, so that the guest, I'm getting my words mixed up. So the host can forward ports so that the guest can connect to a service running on the host. So the short way of saying that is yes. Pull forwarding is great, and it's a new feature, and it allows us to do this.
Okay.
And yes, and the good thing that we have lots of suggestions from our users. So like it's very important for us to develop in a way our community want us to go to. So this feature was suggested in our bug tracker, and we added it. So it's one of the principles how we're developing Code with Me in collaborative manner.
Great. I think we are already in time, so I will only say that this was really well thought of and incredible. And now I am curious to take the first dig at the product.
Great, that sounds brilliant. The button's there on the toolbar. Click the button, get started.
I will for sure. Thanks, Kate. Thanks, Matt. It was really incredible.
Thank you.
With this,
Thank you.
Thank you so much. Thanks, Kate and Matt. With this, everyone, we conclude the second day of UINXT. I hope to see all of you tomorrow at 5 p.m. IST for the final day. We have some power-packed talks lined up on the latest trends in mobile development technologies. So if you are a cross-compiled web developer or a mobile development enthusiast, you got to attend it. And to top it up, we have a super cool fireside chat between the man from the future, Tom Emmerich, and the studio partner for Globant's UI engineering studio, Ritesh Menon. Hope to see all of you tomorrow. Until then, take care.